Yes, okay. Hello, and welcome to Scala IO. Thank you for coming. First of all, I would like to address some thanks. So thank you to our sponsors, Clever Cloud and Ledger. We also have a partnership with Scala. Thank you to EPITA, School of Engineering, which hosts the event. So all of this enabled the event to basically happen. We will have today a community party at L'Âge d'Or, but I don't have the time confirmed yet exactly when it starts. So just ask us during the day. And yeah, I will give the microphone to Thierry Giraud, the Director of Research at EPITA, for a few words. And then Valentin will be keynoting for this edition of Scala IO. Thank you very much.
Thank you, Mark. So I'm head of research at EPITA. EPITA is a French private university in Paris, but also in several other towns in France. Actually, this university is dedicated to computer science, and actually our students have the ability to learn Scala amongst some other languages. Okay, so I'm very glad to welcome you. And somebody told me that there's a lot of French-spoken people, so I will translate my talk in French for those that do not understand. Okay. En fait, donc Scala, comme vous le savez, fait partie d'un groupe de langages assez particulier. C'est des langages dont le nom comporte 2 A, comme Pascal, Java, donc Scala. Et puis, parmi les organisateurs de ces 2 journées, il y a des gens de l'équipe Automate et Applications, donc le nom, l'acronyme c'est AA, encore 2A, donc coïncidence, on ne sait pas. Merci en tout cas. Ça aussi. Ça peut être utile. Vas-y, je te laisse faire.
Valentin Casas for our first keynote of this edition of Scala.
So hello and welcome to Scala IO. You're about to attend the one of the last, if not the last, remaining independent Scala conference in the world. By independent, I mean a conference that is not organized or baked by any company, but rather made possible by a small bunch of dedicated people who volunteer their free time to make it happen. Namely, you have Jonathan, that you have met at the entrance, you have Mark, and you have Lucas, who is somewhere. And I guess they deserve a very warm round of applause. So I wouldn't think that the title of my talk today would align so much with the news from the other side of the pond. Sorry about that. But before we begin, I must warn you, normally the role of an opening keynote is to cheer everyone up and to get them pumped up for the rest of the conference. And today might not be the case, so my apologies in advance. So before diving into it, let me introduce myself briefly. I'm Valentin. I've been a software developer for the past 15 years. I started my career on a very small platform called the Nintendo DS, where I programmed, obviously, on C++. It was a very weird little machine with only 4 megabytes of memory split in different banks where you cannot do whatever you want. It was fun, but a little bit tricky, but fun. Then, because of the crisis in the gaming industry in France, I lost my job, and so I moved on to working in Java, developing web applications that ran on small on-premises racks of servers. And in 2012, I discovered Scala at a conference, and since then, almost, I've been programming Scala, and pretty much as everyone else, my code now runs somewhere in a big data center on the cloud. And during my 10 years of Scala experience, I've been giving talks around the world. I've been building or attempting to build some libraries and contributing to some libraries. I've been helping organizing meetups and conferences, as this one. And so that's it, that's me. But back in the days when I was still on social media, I went by the nickname Override Lazy Val. It's by no chance that I picked these 3 keywords that appear in that order only in the Scala language, because I like this language very much. But also because I am an exceptionally lazy person. It doesn't mean I cannot work, but my brain cannot fathom complication. If someone talks to me about some complicated problem, after 1 or 2 minutes, my brain stops getting the details in and really shuts down. And I'm, and I just forget about everything that's told to me. And that's pretty much why I really like Scala. It's because it allows me to be lazy. With the right tools and the right discipline, the Scala language works more than me when I'm writing programs. You can have, in Scala, basically, if you use the type system correctly, if you use a few functional programming approaches, you don't really need to have all the details of your system in your head. And basically, when I come back to some piece of code a few months after I've been written them, I just had forgotten everything about the detail, but I just need to read the type signatures, the type structure, and I remember what I need to remember in order to be productive and to develop new features or fix bugs and so on and so forth. So, of course, getting to that point where I can take a nap while the robots are working for me, it takes a little bit of work beforehand to teach myself and the little robots how to take care of the garden. And that's a process that yields something that I call the distillation of Scala code. When I tackle a new problem, when I need to program a new feature or start a new project, I start with very naive and simple things that forget about the detail. I write a bunch of case classes or IDTs, a bunch of type signatures. I plug these functions together. Then I start implementing them. And then, because I fail implementing those, I realize that I need to change my signatures, adapt my ADTs, and so on and so forth. And so at any point, at any step in that process, I don't really think, because I am lazy. I just let the structure of the type and the functions work for me. And in the end, I end up with something that is rather simple and that works. So I distill the code. And even more, once you work on a specific project, sometimes you realize that you are doing the same thing over and over again. And so you have, with the Scala language, the possibility to build a small DSL for solving that problem more simply and more concisely. And you end up with a code base where 99% is very simple, very readable, and somewhere you have some boilerplate, some magical code that will do shenanigans with the type system or shapeless or derivation or whatever. So yeah, distillation. And as an example of that, back a few years ago, I was working at a company that had to handle a lot of documents for legal processes. And there was a bunch of rules that we needed to enforce about these documents in order to filter them, to route them to the right processor. And so we were repeating ourselves a lot. And so because I was tired of it and I was lazy, I decided to write a small DSL with nice combinators, symbolic combinators for just solving that problem. It was really simple, just a file with a few combinators. But one day, a guy from another team who was not working in Scala at all, in fact, he had no knowledge of Scala, came to me and told me, you know what, last weekend production went down and I had to fix stuff, and so I had to look into the files where you use that DSL. And it was so simple that despite me knowing nothing about Scala, I managed to make the change I needed very easily, and it worked on first try. And so I felt it very nice because he didn't stop at not understanding how things were working, because he understood what things were doing. Because you can simplify your code that much that the syntax doesn't get in the way. And even not knowing the syntax, you can make changes, and it works on production. So that's pretty much why I love Scala. And considering it such a superior language that has so many features, so many properties that help us kill whole categories of bugs and be so productive, I was pretty much convinced 5 or 10 years ago that Scala was due to take over the whole industry, that people who had to see the light at some point and adopt Scala, that was just necessary. And unfortunately, as more often than ever, I was wrong. You are attending the last remaining independent conference about Scala, but you are also attending the smallest edition we ever had in terms of number of attendees, in terms of numbers of submission to the CFP, in terms of number of sponsors. And it may be just my feeling, but there are not as many job offers around Scala that there were 5 years ago. My boss, who claims that his company is maintaining the biggest Scala code base in the world, also tells me that Scala is dying. So the situation doesn't feel as good as it was 5 years before. So I started wondering why that is. Maybe it's just my feeling because, as I said, I'm not that much on social media anymore and I don't get much news apart from Scala news every week. But I have this feeling that the situation is not as good as it was before. So I started to think and ask myself, why is that? And I came up with a few explanations. First, of course, there was COVID. COVID made us stop having live conferences, live meetups. It also has more subtle effect. If you think about it, Scala has always been a niche language, meaning that for it to get adopted in companies, you have to have someone in that company that believes in Scala and pushes toward these adoptions. And the problem is that COVID also made a raise to remote work, generalized remote work, meaning that even after COVID, when people started to come back to the companies, not everybody was there for the live meetings inside these companies. And if you are not there, it's difficult to push, to advocate about something. I even heard a story about a company that had a Scala code base, but one of the managers was not happy with Scala for probably personal reasons. And that manager took the opportunity of a meeting in the office while the Scala people were not there to decide that the code base would have to be rewritten in Java. And because nobody was there to oppose this decision, the decision was taken, and now they are suffering with Java again. So that's the effect of COVID that stopped the growth of at least the community events. There is another thing that also explains why there are not as many, because the pandemic is past us now. So we should have as many conferences and meetups as we had before, because nothing stops that. But it isn't the case. So that's the moment of the talk when I don't make friends. I think we should also address the elephant in the room. You see, we are a very small community. Don't lie to ourselves. But even though we are a small community, this community is widely divided. There have been lingering conflicts between people inside the community that tend to spread to the people who are not involved in those conflicts. And even though it doesn't show much from the outside of the community, or even for you who are not involved in making the community live, it has probably burnt out a lot of people who, like me, organized meetup and conferences, because people who are taking part in those conflicts, they tend to try to put you on the side of the conflict, even though you want to remain out of the conflict. In Scala IO, we've always thought ourselves as a neutral ground where people could come and discuss, even if they disagree, and even if they strongly disagree, because disagreement is normal. But it turns out that because at some point we invited someone on the one side of the conflict, people from the other side of the conflict think that we are bad. And it goes both ways. So now either side of the conflict, even though we start to remain neutral, tend to see us as the enemy. And I mean, this is a little bit childish. And if you want to disagree with someone, if you want to dislike someone, be my guest. But please stop trying to bring everyone in your own battles. It's probably not productive, and it, I believe, hurts the community a lot. So that's the end of the parenthesis, and I will start trying to make friends again. But this situation, and also the fact that I was facing depression at the time, made me stop using social media and basically crawl into a cave from which I didn't went out that often. So that's also probably the reason why the things I will tell after that might sound outdated or even wrong. That's because I don't get all the information, so please pardon me. But nonetheless, I stick to it. So that was the reasons internal to the community why things are shrinking. But there are also reasons why the community was not as big as it could have been. And I think this has to do with our obsession on functional purity, which I exemplify here with all the monad tutorials that we had. I mean, talking about monads in great detail is really, really nice and interesting once you understand why monads are important. But from the outside of the community, for someone who has not been starting their functional programming journey yet, talking about monads, and especially saying phrases like, a monad is just a monoid in the category of an functor, what's the problem? It's funny because it's a private joke, but if you're not in the group who understand that joke, it just push you back. And by the way, even if it's a good joke, that sentence doesn't bring any insight to me unless you say, it's a monoid in the category of functors, but it's not the only one. That's interesting, because then you talk about applicatives, and that's cool. But otherwise, you are just flexing with big words, and that doesn't move anything forward. So even though I strongly believe in pure functional programming, I think insisting on pure functional programming too much pushes people away. And Scala is an hybrid language. You are not forced to do functional programming with it. It's good if you do, and you should. But if you want to bring people in, I think it's not the thing you should insist insist on in the first place. You can still insist on that, but after they came in, and help them on their journey on functional programming. But honestly, the most reason why the community is not as big as it could be and is not growing as fast as it was is also because of external reasons. First, so that's a kind of reasons that I call fewer or lesser incentives. Things that diminishes the incentives of moving from Java to Scala, for example, is the fact that Java is stealing features from Scala for the past 10 years. If you look at the new language features in Java, they are pretty much all inspired from Scala, which is good. It's a sign of success. It means that Scala was right, and Java is realizing it. They now have lambdas, they have pattern matching, they have case classes, they call it record, but et cetera, you name it. So that's good. It's a sign that we are on the right way, but it also lowers the incentive of moving from Java to Scala because now you also have these features in Java. Even though we know as Scala developers that the Java mimic of the Scala features is not as good as the real deal, but still it lowers the incentive of moving from Java to Scala. Another thing that lowers the incentives of moving to Scala is the way Spark deals with Scala. You see, Spark has probably been the biggest reason why people adopted Scala in the past 10 years. Just by a show of hands, who has started Scala because of Spark? Oh, I would have thought more people than that, but anyway, I'm always wrong. And the thing is, Spark is not really a Scala thing. It's a thing that happens to use Scala. But they are still stuck in Scala 2, and they will probably never get into Scala 3. They now make it possible to use Spark without writing a single line of Scala. And so that incentive went away. And also something very obvious, but the thing is, Scala allows small people to achieve a lot and produce robust software. That is not a good business plan for consulting companies. What you want as a consulting company is to sell as many developers for as long as possible to clients, rather than selling small teams of developers for short times to many, many clients. It's easier if you use Java because you will need 10 Java developers for 2 years for a thing that 3 Scala developers could have done in 6 months. So we have fewer incentives as before. We have structurally fewer incentives as Java for the biggest people who hire, biggest group of people who hire developers, which are consultancies. And so we are a little bit doomed. And before preparing this talk, I have very little time for preparing it. So I ran a survey on 5 former friends and former coworkers. So that's not at all representative. They are all, so we met back in the day when I was doing Java. And now they are still doing some Java for some, or doing Ruby for others, but none of them has ever adopted Scala. And so I asked them, why have you never tried Scala? So some told me, well, I tried, but at some point I ran into a problem. I asked a question on some forum, and my question was met with snarky or slightly pedantic answers that made me feel a little bit dumb. I think that's something from the past. I think that we have amended ourselves from that, but it's true that back in 2010, it was easy to be looked down on chat or forums when you asked beginner questions. I think we did a pretty decent job in changing that. The second thing that came up was that there seems to be so many ways of doing the same thing in Scala. It doesn't feel very mature, and so adopting it feels a little bit risky. And that's an argument that I can understand, but then I answer, isn't it the same in JavaScript? If you remember that joke saying that every day there is a new JavaScript framework, I don't know if it's still the case because I live in a cave, but apparently what's a problem for Scala is not a problem when it comes to JavaScript. Puzzling. Another and very worse argument, because it justifies itself, is from so two sides of this argument. One is from a friend who became a manager who told me that, sure, I could adopt Scala and have find one or two senior Scala developers for building a system. It would be robust and good, but then they will leave, and I have no idea how I could hire more people because there seems to be such a small market. And another one who is still a developer told me, I never invested too much time on Scala because there are not so many job offers. So you see how this justifies itself. There are not so many job offers, so I won't learn Scala, so there are not so many developers, so there are not so many job offers, and so on and so forth. But isn't that the same with Rust? I mean, where are the 5 or 10 years experienced Rust developer out there? They are nowhere to be found. So it means that companies are willing to train people to become Rust developers, but they are not willing to do the same for Scala developers. And in fact, the friend who is a developer who told me I never invested on Scala because there are not so many job offers, works for a company that runs trains. And they have 2 departments for software. One for web application and data, where they use mostly Java, and Scala is almost forbidden by law, by internal law. And they have another department who write C and C++ for actually running the trains. And this department, they are making or producing new Rust developers because they are all in on Rust for replacing C and C++ in their systems. So that got me puzzled. How come some seemingly rational arguments are applied to Scala, but not to other languages? And again, I think it's a matter of incentives. If you want to have some code run in the browser, you have no choice but to write something, at least something that will produce some JavaScript. You could use Scala.js, but that's another question. So JavaScript is there, and you have no choice. So the incentive is much bigger than, yeah, it doesn't seem very mature. There are so many ways to do the same thing. That's not a problem because you have no choice but to use JavaScript. And for Rust versus Scala, they both share the same properties of enabling developers to make all classes of bugs not representable. So that should be the same for both. But think about what kind of systems are built currently with Java and what kind of systems are built with C or C++. With Java, we basically ultimately produce web pages or dashboards about data. If something goes wrong, somebody might lose a lot of money, but nobody gets hurt. Whereas systems that are built in C and C++ are mostly embedded systems or systems for driving train automatically. And if something goes wrong, people get hurt for real. So the incentive of suppressing all classes of bugs is bigger when these bugs can hurt people rather than when these bugs can, at worst, make somebody lose some money. So I think that's the reason why so many companies are keen to make Rust developers out of, not nothing, but out of C developers. And at the same time, so few companies are keen to make Scala developers out of Java or Python or you name it, developers. So as I said, I didn't cheer you up. I see your faces, and I think I did a pretty good job in that extent. But of course, I won't leave you without a few specks of hope. So first up, in order to welcome newcomers, because we will find a way to have people come to Scala again. And a recent experience of mine raised that idea. So as I said, I had in the past few years a few episodes of depression. And when you live in a cave and work 100% remote and you are depressed, your productivity is not that good. And in both cases, I was literally saved by doing some pair programming sessions with coworkers. And more specifically with coworkers who were not very familiar with Scala. And so we sat down for 1 or 2 hours on a video conference, and I explained them how we did this and that in the project. And after those, I was motivated again. I was happy, and they were happy, and everybody was happy, we're happy, and it was awesome. So I was thinking, what if, and probably some of you for their projects or libraries are already doing that, but what if experienced Scala developers could volunteer small amounts of their free time, like 15 or 30 minutes a week, for example, in order to do pair programming sessions with newcomers who have problems. Because you see, when you're a beginner in something, asking a silly question, a question that you think is silly, in a public chat, it can be intimidating. And answering these kind of questions that you might have already answered dozens of times, it's easy to do answers that are a bit dry or do not make the people who ask them feel very welcome. Whereas if you sit together for 15 or 30 minutes, talking about the problem and meeting each other for real, first you may have a chance to make new friends. And I think it will be a much better and much more productive experience for both the side of the question. Not only for the people asking, but also for the people answering. Because sometimes when answering a question and seeing that the person that get the answer didn't completely understand what you said, you ask yourself, did I answer correctly? Did I explain myself correctly? So everybody will progress if we do that. So if you're interested in helping me making that happen, let's talk after the presentation. Maybe we can come up with something very simple, but that would make that possible. Second idea, and I think that's something everybody can start doing in their own companies, has to go with not agnosis, but persuasion. I think we are, or every one of us, are the best advocates for Scala and for functional programming. We just need to do it right. I am currently working with Databricks. We are building a transpiler that is supposed to be able to take SQL queries in pretty much any dialect and translate those in the equivalent query in Databricks SQL, but also help to migrate workflows and notebooks and these kind of things. When I interviewed with the guy who will become my boss, I talked at length about a previous experience where I did similar things, translating Sparkle query language for RDF into Spark, using purely functional programming, recursion schemes, and all the good stuff. And at the end of the interview, he gave me some feedback, and he's a very no-nonsense person. Very smart, but no-nonsense. He detects bullshit at 1 kilometer. And he told me, I don't give a crap about your functional programming thing, but you seem to know what's the kind of problem when transpiling from one language to another. You seem to have at least common knowledge about the Spark internals, so I will hire you. And so it's the guy who claims that Databricks, and I believe him, is maintaining the biggest Scala code base in the world. And as such, they have very strict guidelines about how you should use Scala. The rule of thumb he gave me was if someone needs to wake up at 4 a.m. because production is on fire, they shouldn't need more than 2 minutes in order to understand any file in the code base. I think it's a good rule. But as a result, there are many things we are not allowed to do with the Scala language. The biggest is we are not allowed to write the word implicit. So that makes for a very dumbed down Scala. And of course, cats is out the window. Recursion schemes are out the window, obviously. And so I was a little bit baffled and frustrated at first. I thought to myself, well, that won't be fun. I will suffer a lot. And in fact, turns out I didn't. It's pretty smooth. It's refreshing to do Scala as just a better Java. But of course, so we are building a massively recursive program that passes incoming queries, traversing that tree to translate it to some intermediate representation, then traverse it again to make some optimization, and traverse it once again for outputting a string that contains the output query that we have translated. So a lot of recursion. And of course, because we're initially using Scala just as a better Java, we were relying on exceptions for control flow, because why not? And of course, because SQL dialects tend to be a little bit complicated, it was obvious that we wouldn't get it right on the first try, but rather incrementally improve our parser and generators and so on, thanks to a whole lot of test queries. So basically, we have unit tests, or coverage tests, or acceptance tests that fail a lot, and we try to make they fail less. But the problem is when you rely on exceptions for doing that, your program stops at the first exception. And so for the same query that may have multiple problems in it, you will have to run the test multiple times until you get all the errors. So when that problem became really prominent and was preventing us from making quick progress, I suggested we used some kind of, is it readable? It's not readable. Some kind of, I never said the word monad, but some kind of monad. So if you have good eyes and can read this, it's called result, and it's some kind of hybrid between either and validated. So it's a monad and an applicative, if you want. You have 3 cases: OK for the happy path, KO for errors that are not recoverable, and partial that will still try to build something, but also accumulate the errors you have encountered thus far. And of course, once you get a partial, you can never get an OK again. You will remain in partial unless you have a KO, where you will be a KO and everything will stop. And because that was solving an actual problem we had at that moment in the code base, my boss accepted that I refactored everything to use this result instead of throwing exceptions when something went wrong. A while after that, not that long after that, by the way. Oh yeah, and error is our own type of error that I made a monoid so that it works. But of course, never write the word monoid, never write the word monad, never write anything like that, no implicits. It's just functional programming in disguise. And a while after that, we realized that for migrating workflows and notebooks and so on, we would need to also output some Python. And the problem with Python is that it's an indentation-sensitive language, meaning that you need some way to keep track of what level of indentation you are. And so my boss got a first stab at it. He put a context object in every function with a variable in it a mutable variable in it, and he incremented and decremented the indentation level. And of course, he ran into problem because sometimes he forgot and the output was all broken, and it was difficult to track where the error occurred. So that's when I came up with this new monad, without saying that this is a state monad. But it is a specialized state monad with a state called phase, which is something where we say where we're at in the tree, where we're at in the process, and also we have an object for indentation and formatting. And it wraps around results so that it can also accumulate the errors, and that's it. Very little bunch of lines of codes. Again, no magic. The signatures are acceptably not too complex. So, and because, again, it was the right moment and it solved a problem we had, currently, I was allowed to do that. And finally, that's where I, again, stopped making friends because that is dirty. Finally, we needed, because we are in a vastly recursive program with explicit recursion, and we also have a whole part of the team who is coming from Python and not very familiar with Scala and functional programming, so knowing where to put the flat maps and so on is not an option for them, at least for now. So I decided to wrap everything in a string interpolator that basically acts as my applicative combinator. And that's the two instances. So I have this extension method sequence for sequencing a bunch of my, a list of my state monad. And this interpolator, these are the two instances of the word implicit in the whole code base. Its implicit class is almost okay with the guidelines. And in the end, it allows you to do these kind of things. You have the code interpolator. Expression is basically the recursive call for the rest of the generator. And you just pipe things together. And if any error occurs, for example, in array access here, if an error occurs in the first or the second or both expressions, you will get both error at the end. And you will still get something output, but with comments around the errors. And everybody is happy. The code is fairly readable and almost easy to write. And we are happy, and people are starting doing functional programming without even noticing it. And that's my point. I had to put some code on some slides, but that's not really the point. The point is that if you want to convince people about something they are not convinced about, you cannot go up front, as I did during the interview, bragging about functional programming and recursion schemes and so on, because they won't care about it. They won't be convinced. You have to wait for the people to suffer, and then you propose them a solution for their suffering, and then you convince them. So I think it's our duty, everyone in this room, to be aware of when people are suffering, and then boom, you propose a solution. Later in this conference, you will have talks about full stack Scala, for example, and demonstrations on how you could scaffold a full stack Scala application in a matter of minutes. So watch this talk carefully, and when your boss needs to find a way to spawn a new small web application in a hurry, you will have something to say, hey, I can do full stack Scala. Look, it's a command line, and bam, you have a Docker that runs and everything works. So it is our duty to remain aware of moments where we could push our pawns or play our cards in a very effective way and non-violent way. Like, it's not, Scala is better. I have the truth, and just believe me. People won't believe you. But if you wait for the right moment, you will certainly have a good point. And finally, I think, but this is only vapor, But I keep thinking about what could make Scala unique to the eyes of the outside world. And one feature that we have that no any longer language has is tasty. And tasty is awesome, and I believe we are not using it to its full power yet. And so my hunch is that the next killer thing coming from the Scala community will make a creative use of tasty. I have an example from Jonathan. We're starting to use tasty as a serialization format, for example. It's fairly simple. You compile a small file that just creates objects. Then you get the tasty file for it. You ship that tasty file. And on the receiving end, you load that in a class loader, and bam, you have data. And it works even if you have different versions of Scala on both ends and so on. So we could imagine something very crazy that tasty makes possible, and that would be impossible or impractical in any other technology. And if we get that, it will bring the incentive back because we will have something that the others cannot have and cannot steal from us. So again, it's your duty. I lack imagination, but probably someone in the room will have the imagination for finding smart ways of using that features of ours that nobody else has. And so lastly, and more importantly, I think our duty is to share our enthusiasm, our love for this language, talk more about our success stories. Even though we don't think it's that much of a success, I think we need more success stories. Like even a small post on Twitter or whatever saying, oh, today I did that and that made me feel happy. And share the love of Scala. And that's, I think, the only way to get this community become vibrant again. So yeah, that's it for me. Thank you. I think we're already late, so I won't be taking any question now, but you can find me in the lobby if you want to discuss or tell me how I was wrong all along. Thank you. Ça va, c'est bien? Je sais pas chronométrer du coup.
Ça va. Je regardais voir un peu, mais...
Pour l'instant, enfin si on en a produit un mal, mais oui, mais parce que lui, il n'est pas fait pour longtemps.
Ce que je veux dire, c'est qu'en fait, moi je pense que...
Tu penses qu'avec des nouveaux profils, on va pas avoir plus de résultats en changeant pas trop de méthode. Alors. Et sinon, il y a aussi à l'école. Il faut former les petits genoux. Il faut former les petits genoux.
Je sais pas exactement.
Moi, c'est. Ouais, ça fait. C'est pour ça que j'ai répondu en avant. Il y a puissance qui est si grande. Ouais, mais pas assez. Enfin, ou alors t'as pas le besoin de recruter ton équipe.
C'est-à-dire que les équipes dev, ça coûte.
Mais ce qui paraît logique en même temps. Quand on automatise, t'as pas besoin de recruter des mecs.
J'ai envie de faire de spin. Ça sort plus.
C'est bien parce qu'on va vite dessus.
Mais t'as pas besoin d'être chef, t'as pas besoin d'être chef. Continuer à faire le truc technique.
Non, mais peut-être que ce qui fera un peu évoluer les choses, c'est des petits consortiums. C'est des petits consortiums d'entreprises qui font jusqu'à là pour justement peut-être des trucs genre.
Back in 2010, and they stuck on this.
Yeah, I think that's what you when you left there. They wrote a plan. One of them was yeah, actually 23 was very powerful. There was musical players and anyway. Yeah, I know. Yeah, I'm recording. Yeah. Sorry? No, I will be working Sorry? Yeah. There was a part for recruitment that I will be like having a little bit less hours because my well, according to law, 3 months, right? Trying to but she more or less here I've come to yeah, hold on. I hopefully something like December maybe. Yeah, and I read for like six hours or something currently, so you don't have to really do anything. Apparently I'm done. Oh. Okay, but anyway, what's can you Yeah, I know. Yeah, but basically the whole thing about this, those are for me to talk to you. That actually seems pretty cool. I think everything, yeah, after something, nothing, there's very little things anywhere you can do what you want. You can, I see that you tend to learn the hardest things in the job. If you have a guy as a leader that you can trust, that's seriously, that's
speak as long as you do. Great.
J'ai un souci, c'est que moi, je sais pas si ton nom il affiche, mais moi j'ai pas ce slide. Ça passe bien au système, mais moi j'ai rien. Je peux changer, demander d'avancer 2-3 slides dans les off, que je vois si je les ai bien. Ou s'il peut revenir à l'écran de base qu'il avait. J'ai rien. Parce qu'il peut sortir de la présentation que je vois son fond d'écran. Non, j'ai rien. Alors c'est ailleurs. Là c'est bon. Ça marche pas. Oui, ça je suis pas inquiet, on peut les remettre en poste, mais c'est... comment dirais-je, c'est... enfin, pour la réalisation, ça fait du boulot après. Oui, non, je veux... mais c'est... parce qu'on a le même souci que je veux. Oui.
C'est possible,
parce que là, pour les 2 jours, jusqu'à demain soir, c'est en conférence au Scala IO. Ah, je suis pas sûr que...
On m'a dit que ce sera en amphi 401.
Ah. Peut-être voir avec l'école, du coup, parce que là... Ils vont peut-être réaffecter ailleurs. Je pense que je sais pas si c'est la révolution ou ce qu'ils vont avoir. Ça remonte là jusque chez moi. Je suis en cherchant de savoir rien changé. Moi j'avais tout le truc en plein nickel tout à l'heure. Donc je vais voir à côté. Moi je ne considère pas signal, je pense que c'est un problème de résolution là. Il ne remonte pas. Vraiment quelqu'un qui peut le câble, mais je ne vois pas. De toute façon, ça sent comme une salle, on enregistre. On enregistre donc le son, l'image, le feature, et en faisant en sorte à ce qu'on voit les trucs, on va se faire de manière à ce qu'on puisse recaler les images. Le pire, c'est qu'on ne parle pas de la référence des slides, c'est-à-dire pour les avoir. Et moi, je vais faire un protocole de speaker et ça va.
Can I have your attention, please, for just a very quick announcement? So the lobby here on the 4th floor is very crowded. People are standing shoulder to shoulder. We also have access to the 5th floor lobby, which is much larger and spacious with couches and places to plug your equipment. And there are 2 toilets on the 5th floor. So it's a lot easier than just one here. We only have one here because the auditorium is taking up space. So feel free to park yourself on the 5th floor, just relax, small meeting.
Hello everyone, can you guys hear me? Alright, my name is Adam Hearn, and today I'm going to give you, hopefully, a brief introduction to Kyo. We'll see how long it takes. I chose a dark mode, and I hope that's alright with you guys. I figured a lot of programmers really enjoy that.
So, if this is your first time hearing this word, it's all right. I think we might have heard of ZO, we might have heard of Cat's Effect, but what is Kyo? I think this is probably what everyone's asking. So, honestly, Kyo is a lot more than an effect system, which we may already realize. It's actually a bunch of standalone modules which form this really powerful toolkit. So one of my favorite modules is Kyo Data. These are basically low allocation alternatives to option, to either. These things are really powerful, and I think when you enter the workshop or when you just see the code, you may not see the value immediately, but on a larger code base, it becomes quickly apparent that these provide a lot of value. So this is sort of the magic one. This is Kyo Prelude. This is where effects are handled. This is where effects are defined. And it's very cool because the approach is to have a side effect-free module. And so if you wanted to use this as an alternative to other Prelude libraries like ZO Prelude, you can completely avoid side effects in your business logic just by taking a dependency on only Kyo Prelude. There's also Kyo Core, and this is necessary because we need I/O, we need async, we need concurrency. These are very powerful constructs, and Kyo Core is what I use. But if you have a more pragmatic approach with purity, then Kyo Prelude is definitely for you. So then there's the Kyo Scheduler, and this is actually sort of the secret sauce for how Kyo Core is so fast. It's a very aggressive, high performance, and adaptive scheduler. I've noticed using it in my production application for about 2 months now in my personal time. And it's been very good, and it's used limited resources to do a lot. So if you're using a ZO app right now, you can actually just take a dependency on Kyo Scheduler ZO. It'll replace your existing runtime and executors, and you'll be able to run your whole application with the Kyo Scheduler. Okay, and of course, we have integrations with Kyo ZO and Kyo Cats, which enable you to trivially convert between effect systems. Okay, so this is the big question. What are algebraic effects? And unfortunately, before we dive into algebraic effects, we probably should talk about effects in general, because as programmers, we like to have our own definitions for things, and this becomes a problem when we talk together. So, effects are probably the most overloaded term in functional programming. Most people end up describing side effects, not functional effects. So effects are really just descriptions of what you want. And the important bit here is that they produce what you want when you run them. And I think one of the values here is they give you programs as values, which if you've been programming for a while, you'll realize this enables you a high degree of flexibility in how you use your programs, but also the understanding of your programs. The important part for effects, or how they're implemented, is that they're backed by suspension. So deferring the computation until later is very important to enable powerful combinators like retry, delay, all these things that we've all used. And this is because there's a separation of the execution from the definition. So this also enables delayed implementation. For example, if you've used a test clock or a live clock, you know that we need to have these separate implementations. And if you're writing in an imperative style or even just Scala sort of imperatively, you realize it's very hard unless you're going to pass an implicit or you're going to pass a parameter with a clock everywhere. It's very difficult to just use a test clock. And so what a lot of us end up doing is we end up adding retries or flaky, at flaky on the annotation of the test, but this is really not a solution. This is sort of a Band-Aid. And so, yeah, Kio of course provides this, but so do many other effect systems. Okay, so now we have effects. Effects are essentially just suspension and description of what you want. What are algebraic effects? Essentially, they're just extensible and composable effects. So they provide you fine-grained control over effect handling, as well as trivial combinations of various abilities. And the important part is actually this, just like effects themselves are the separation of the definition of code and the execution, algebraic effects should enable separation of effect declaration and implementation. And this is sort of mind-blowing at first, but effect handling can be distinctly defined, and so even users can create their own effects and run them using the core features of the library. So handlers are simply defining how effects are interpreted. Okay, so why use algebraic effects? And I'm probably the worst person to ask about this because at work I use Zio. And I think algebraic effects offer a lot of promise and they offer a lot of value. And personally I am using them and I'm writing a lot of code with Kio. But I can't give you that answer. If you're using tagless final or if you're using Cat's Effect or Zio, I encourage you to give them a shot and try it. But I don't think there's an answer because algebraic effects are sort of this novel new thing that has not found a footing in terms of why use them. Okay, I can give you an answer though to why use Kio. And this is maybe more important. First of all, it introduces extremely flexible algebraic effects to Scala. I'm not aware of any other library that's introducing the ability to have user-defined effects in Scala. And this sounds very minor, but if the whole point of using algebraic effects is effects, many of them, different abilities, then you want to be able to define your own. So the other thing is Kio is designed for an immense level of simplicity as well as performance. One of the things that I see with beginners or new users of effect systems is you sort of get this memorization or die. And what I mean by that is we've all been writing code before and someone else on the team comments, well, why don't you just use this combinator on this effect using this, and you sort of, your mind explodes a bit because you're so frustrated with seeing constant combinators and different ways of doing the same thing. And Kio takes a different approach, which is simple pragmatic APIs with the goal of allowing users to easily be able to find what they need. And of course, Kio enables custom user effects. Okay, so Kio syntax. This is probably going to look a little bit confusing, but let's talk through it. So the most important thing here is actually this is a val. And so, of course, effects, because they're lazy, they can be defined as vals. And even if it includes side effects, this will not execute the effect. But you guys all probably know that. So next we have the string. This is the result type. And then we have this weird less than symbol, which is actually like what we call the pending pending type. And so what you have on the right is the pending set of effects. And so here we just have string pending IO. In Kio, effects are represented as an unordered set of effects. And so when you see the pending type, you might actually see it more representative of this here. So you have file, pending, IO, and resource. And so the beautiful thing is you can individually handle each one of these effects and transform an IO and resource to a IO. Okay, so we kind of understand Kio syntax, we kind of understand what the algebraic effects are. Let's talk about how we use them and what effects, some of the effects that Kio brings. So IO. The above expression is a little bit interesting because we all use IO in our code bases. But one of the things that's important here is that IO is not different from any other effect. It's actually just a tag. In the sense that IO is just a simple suspension. It provides no additional functionality, but it enables you to specifically label all of your side effects. In other effect systems, everything elevates to IO, and I don't think that's necessary in Kio. So let's see here. You can handle IO individually, but for the most part, you're probably going to build your application, put it all together, and not actually run it. Your main app will run it. But of course, you can use the unsafe run. So one of the interesting things here, which maybe I should gloss over for now, is that you can notice once I've done this run here, what is the type? It's this chunk of person with pending any. What is a pending any? Well, it turns out that there actually may be additional suspensions, and there may be additional effects, even if they're not necessarily represented here. And the reason for that is because the core library needs to introduce suspensions for things like locals, for things like stack safety. And so, yeah, we'll move on for now. But I think that's an important thing to notice. OK, abort. So if you've ever written Zio-style code, you know it's extremely common to use the E-type as your short circuit. And the beautiful thing in Kio is you can explicitly use that when you want. So instead of having this Zio, any, nothing of A, you end up with just leading the entire expression. So it becomes just user pending IO. In this case, it's actually simpler than that. We just have a user pending abort. And the abort has a specific type. The cool thing is you can actually add many aborts together, and they can introduce those all into the type. And they can be used using type unions. So this is Scala 3 only. But as you can see, when I write this code here, I'm able to trivially switch between effects, and it's visible in the resulting expression. Abort, when run, produces a result, and a result is very similar to an either, with the exception that it can also introduce panics, which are, of course, system-level issues, but that's not really relevant here. Of course, we all want to have the Zio R-type enabling the dependency injection for passing in context where necessary. And this is a very simple example, of course, but the beautiful thing is you can add many different environment types wherever you want, and you can actually handle them all individually, or you can handle them all together. And we'll talk about that more in the workshop. Okay, this is the beautiful part about Kio, and I think this is one of the reasons composition feels so fluid. And this is because effects are able to be widened. So not only can I widen a pure value to be an effectful value, but I can actually widen a value that has effects to have more effects. And this seems like, at first, you're like, why would I ever want to add more effects? But it turns out we've all suffered from this problem when branching. How many of you have used Zio.win or some other combinator in Zio where, or another effect system where you need to branch, or the dreaded if X do Y, and then in the else case we need to Zio.succeed of 42 or whatever. That is a real pain, and it becomes very, very, very bothersome very quickly. And so with Kio, you can actually just say, in the if case, you can do or the else case, you can do your effectful expression, and then you can just return a pure value in the other case. So yeah, this is super useful for allowing flexible and composable code. And the sort of secret is that plain values can be widened to Q computations. And I will note that widened values are not suspended in the general case. There are instances where they will be suspended, and this is generally not a problem because if you're using pure functional programming, your expressions should not be unsafe or mutating, which is why in general you need suspension. And widened values do not allocate. So there is not only are widened values not saying, like when I write this, there's no implicit lift to a 0.succeed. You're not introducing a box here. You're actually just widening the type. And so the beautiful part about that is that you can have very complex expressions which sometimes use effectful values and completely avoid the allocations for that. The other thing about Kio is that you get this beautiful unnested encoding. So if you notice, this function I wrote here, so this is a write object with an apply method. And it accepts this Kio computation returning a string with any number of effects. And we're going to get the value using map, and we're going to write it to some buffer. And apparently that buffer uses IO, so that's interesting, I guess. And when we look at the code down here, you might notice that value is actually just passing a pure value. And if you look at the effect version, you might notice that console.readLine can actually abort. And so now we've introduced multiple effects here, and this is all apparent in the type. But not only that, but if you look at the original apply expression, we're just using map. And this is sort of the secret beauty of Kio, because with a map-only expression, you actually don't need this sort of flat map. And so all effects are included when you do a map. All the effects get joined into the right-hand side of the expression. And so you sort of avoid this constant question of, should I use map? OK, now I need to introduce effects. OK, now I need to turn that to a flat map. Oh, now that I have a flat map, I need to do 0.succeed. This has really created like a beautiful way to write code. And this actually completely removes this whole category of code and simplifies how your expressions are written. So this is obviously a simplified example, but flat map is map. So yeah, the other important point here is the resulting type includes all pending effects. And so this is important because if you pass in some expression that contains pending effects, it's not going to just discard those or lose those. Instead, it's actually going to just combine those all into the right-hand side of the expression. OK, let's talk about effect handling. So let's start from the top. A is just a pure value. It's being widened to a computation of int pending abort of exception. All right? And you'll notice that on the second line, B, I'm invoking this abort.run. And abort is able to handle one or multiple aborts. In this case, I decided to handle them all at once. And since there's no type union or multiple aborts pending, we end up with just a simple result of exception or int. You'll notice it's still pending any. And as we talked about earlier, there may be additional suspensions. Obviously here, there's not going to be any remaining suspensions because we're passing around a pure value. You'll notice the b.eval, and this is how you take care of those pending suspensions. This is pretty rare in actually user-defined code. It's more important if you're defining a library or if you're designing something internal to your application which needs to use unsafe logic. So this is something that's not visible in the slide, but important to note. Ordering of handling can actually affect the result type as well as the potential value. And so you can envision the case where I may have multiple aborts with multiple type unions, and if I handle one abort at a time, the resulting type may actually be different. You know, it might be a result of error 1 or result of error2. And so you end up with this sort of complex type, but that's not really going to manifest itself unless you are doing some very explicit effect handling. And in general, I've found in writing my own code that the effect handling order is almost completely irrelevant. And instead, you'll just use effect handling where you want to manually or explicitly change the type. So one cool thing about Kio is there is direct syntax. I'm not a fan of direct syntax simply because I like fast compile times, but actually the syntax is quite nice. It's very beginner friendly, so if you're introducing this to someone at work or a friend who doesn't know anything about Scala, this really creates a way, if you've written Rust or if you've written JavaScript, from my experience, this feels very similar. And the cool thing is this is just, of course, transforming to map under the hood. So the Kio app, running your application. I found this a little bit funny because this morning I was trying to think of an example of what I should provide on screen that would be concise enough that you could see this. And I realized that I can actually just show you how to build a server in Kio. And so I'll walk you through that. Kio provides, of course, system utilities. And in this case, I'm just asking for a port. You notice I'm using the defer syntax. And of course, this is direct style. You don't have to use this. You could also use a for comprehension or just map. The beautiful thing here is in just a few lines of code, we're able to build a server, run it, and you'll notice there's actually no explicit effect handling. And one of the things where I didn't include any type ascriptions, but routes, when I call routes.add, this is actually not a mutating operation. Instead, this is using a sort of state monad or whatever you call it. And in this case, it's actually just an effect called emit. And so when I run this server, I'm not only am I explicitly handling this routes effect, but I'm also starting the server, and you'll notice it doesn't feel complex. I think a lot of people view algebraic effects as this magical thing that should be very hard, and they don't understand it, but really it's quite simple. And for the most part, you'll find Kio to be quite simple and easy to use. So what is our conclusion? Kio provides a simple and powerful way to work with algebraic effects, and amazingly, that's available in Scala. It offers composability, type safety, and performance. I've really been impressed by Kio's performance in my personal projects. I've found it to be highly performant and very, very easy to use. It definitely enables a cleaner, more modular way to introduce functional programming, especially to those who maybe have no experience. And I've noticed this when teaching a friend on how to use Kio, and they had no idea what, of course, tagless final is. They don't know what f-bounded polymorphism is. They hardly even understand how Zio works. And in maybe 4 weeks, they were able to be quite productive in a Kio code base. And it's been very cool to watch them start to understand how Kio works. All right. Do we have any questions? In the back?
Yes, 1 minute.
I think next time I'll include an example of how to convert your f-bounded polymorphism or tagless final into Kio, but I didn't have time for that this time.
Hi, thank you very much for the very interesting presentation. There is something that I didn't really understand. You use in the same way the term user-defined effect and algebraic effect, and I will know what is the difference between them, that are the same thing. And if it's the same thing, what are the algebraic nature of the algebraic effect of Kio?
So you said the difference between an effect and what?
No, user-defined effect and algebraic effect.
So a user-defined effect is actually, there's no difference between effects, and let's go back here. So effects in general are simply just abilities. And for example, the abort ability is implemented in what could be user code. However, it's included in the core library because it's extremely useful, extremely helpful. It'll be commonly used. And so the effect handling is pretty simple, and you can probably go look up the definition, and I think it's less than 100 lines, including all the combinators and all that. And so the reason I bring this up is because you can imagine a world where, take a step back 5 or 10 years in the Scala world, and everything was monad transformers. You were using monad transformers to change from one type to the other, and no one was bringing this sort of bifunctor approach of ZIO or these other more advanced types that we have now. And if you wanted to introduce your own, I guess, change to the library, you would introduce a monad transformer, and you would have to call it everywhere, and you were constantly lifting and unlifting and running your code. And this was like very complex, and at work I have a code base that I really do not like touching because it's Scala Z and it's monad transformers and it's a pain, and this could have actually been completely prevented by just defining a single user effect, and it would be able to be just run individually or removed individually, and you wouldn't have this complex problem.
Excuse me, that was absolutely not my question. You use in the same context the term user-defined effect and algebraic effect. And my question was, is that the same thing? And if user-defined effect are algebraic effect, what is the algebraic nature of algebraic effect? So for example, in a language like Coca that introduces algebraic effect, there is 2 levels of effect definition. The first one is on the core library and are algebraic effect with equational reasoning approach. And the second one are user-defined effect that allow to just define resumable exception that are always reduced to algebraic effect. And there is, I guess, 8 different algebraic effects that are a very precise semantic textbook for advocacy in 2003. So what are the algebraic nature of algebraic effect of TO if there is really an algebraic nature?
So it's actually, it's very hard to hear you down here, I'm sorry, but I'm not going to give you, I don't have a technical mathematical explanation for algebraic effects, but you can of course provide one or look into one. Coca, as you mentioned, is a very good implementation of algebraic effects, and I think they may provide the ability to do user-defined effects. When I say a user-defined effect, I'm not talking about a user-defined effect system. I'm just talking about like a single effect. Let's talk after.
Question from somebody who doesn't understand anything about effect systems, but you're using this ampersand operator between type names.
Yes.
And you keep calling that widening. But isn't intersection narrowing, not widening?
So I think this depends on if you're doing an input or an output channel, and it's a very hard thing to define. But in this case, the intersection of effects is reduced by removing effects. And so it's narrowing the type to be more precise, but I mean it's widening because it increases the scope of what needs to be handled. So in this case, even though the expression's pure, even though it's just a simple value, by adding these additional abort and resource, I've widened the set of what needs to be handled. And so yes, it's more precise type, and technically that's a type narrowing. I think it's a very difficult thing to explain unless you use the term widening, because that's really what it is it's increasing the scope of the effect. Is that helpful?
Hi, thanks for the presentation. Very interesting. There's something very hard to understand. So, few slides before with the different example. So the UX-style approach, is it really learning the Scala compiler and finding their style and harmony, or is it some transformation that transforming into the use map?
So it's using the CPS awaits defer plugin. I think it's technically a compiler plugin, but I believe this could be done fully with macros. So this could be userland code. I haven't actually looked at the implementation of the direct style because it's something I don't use. But truthfully, there's a lot of ways that you could define your own user-defined defer await syntax, and I actually have there's a few ideas of how you could do it with simply functions, but you would not get this nice type descriptions here that you're able to use. So yes, it is just map and flat map, and the Scala compiler ends up seeing, at least once the transformations are complete, just map and flat map.
Thank you. Thanks for the presentation. If I have a ZIO application and I use the ZIO scheduler you mentioned, does it mean that the effects from the IO and the effects from the KO will use the same scheduler and then send the script root, things like this?
Yeah, that's correct. So if you, as long as your application, now this is a very common mistake I see. Somewhere deep in your Zoo application, you have somewhere that you say runtime.default.unsafe.fork or whatever you may have. And if you do that, you are now introducing the default runtime no matter what. But the way that Zio works, there's a fiber ref, which is simply a way to propagate locals across I/O suspensions. And of course, this fiber ref contains the executors you should execute on, the actual thread pools. And so the Kio scheduler Zio just taps into that and provides a alternative runtime for your application. And thanks for bringing that up, actually. It's very important to note that you're not, by using that scheduler only, not only is it compiled for both 2.13 as well as Scala 3, but also it's not converting your effects to Kio or something. No, it's actually just at the scheduler level. So it's simply accepting a runnable or whatever the equivalent is. So.
What's the question? Thank you very much.
Thank you.
Us about single-type implicits in Scala 3.
Thank you. Hello. So my name is Magda. I'm a Scala developer at Software Mill, and I'm very happy to be able to be here today and talk to you about implicits in Scala 3. So to start, I have been a Scala developer for 7 years now, and right now I can say I like it. I enjoy writing Scala every day. But it wasn't like that the whole time. In the beginnings, I was really struggling with understanding the various concepts in Scala. And one of the things that confused me the most was implicits. There were times when I thought, okay, I got this. I finally understand implicits. But then a week or two later, I came upon some other use of implicits and I was totally lost again. So I had to go back to my more experienced colleagues and ask them, sorry, I know we have already talked about implicits, but can we please sit together one more time? And can you explain to me what happens here? What is trying to be achieved in this piece of code using implicits? Fortunately, my colleagues were very patient. So I got through this difficult phase and I didn't give up Scala altogether. But it was close, I must say. But I kept thinking, why does it have to be so difficult? So when I heard about Scala 3 and I heard that the concept of implicits is going to be worked on in Scala 3, that got me, maybe this is a change for the better. So this is how this presentation was created. I would like to share with you what I have learned. So the plan for the next half an hour is I will tell you why implicits are important, why do we need them in the first place, what are the problems in Scala 2 with implicits, and the main part of the presentation will be 7 use cases where I will show you the old code, the Scala 2 code, and Scala 3 code, so that you can see how to achieve the same thing using the newer version of the language. And then I talk a little bit about migration. So what are implicits? Why do we need them? Generally, in Scala 2, the implicit keyword can be found next to various language elements. So, and you can use it to define many different things, to achieve many different goals. But what's common is that they define so-called contextual abstractions. So when you write your code, it doesn't exist in void, it exists in some kind of context. And then you can decide that because of that, you don't have to write everything explicitly. Some of the things you may let the compiler infer from you, infer from the types. So that's why it's called contextual abstractions. So this providing context is the main area why we need implicits, but because they are a very powerful feature of the language, they can be used to achieve other things as well. So they are also used widely in Scala and in libraries to things like adding functionality to your code, to your types, to define type classes, which in itself are a very important and powerful feature, to provide implicit conversions between the types, to provide dependency injection, express capabilities, compute new types, and prove to your compiler some relationship between the types. So for all those goals, for all those needs, you can use implicits. So they are powerful. They make us powerful because they let us do with our code what we need to achieve. But at the same time, they can also make us miserable. And why is that? In my opinion, the most important problem is that you can find the implicit keyword next to parameters and arguments, values and objects, methods and classes. So it's not like you see the keyword and you instantly know what is being achieved. You have to have some experience, you have to know the idioms, the patterns, the ways of solving things in Scala to understand and recognize what is being achieved in the piece of code that you are looking at. So it's not clear just from the keyword. But also there's a problem of imports. So personally, I have spent hours trying to chasing the right import. Because sometimes you have one class and it compiles, it's fine, and then you copy some code to another class, another piece of code, and there it turns out your code doesn't compile. And often the problem is that you are missing an import, because in the first class you had a long list of imports, and one of the 20 imported or fetched into scope some kind of implicit that is needed for the code to compile. So you need to scan this list of imports and guess, is it maybe this import, is it that import? Let's try this and maybe it will magically fix our code. Or even worse, you remember that sometime in the past you wrote this code and it compiled and it worked. And now you're trying to fetch it from memory and you don't remember the import and you don't know how to find the right import. You know that it exists somewhere, but you don't know what it is. So this was a problem for me. And another problem sometimes can be that you try to import too much. Or rather, you don't try, but somehow too much is imported. And this is a problem with implicit conversions in Scala 2, that sometimes in the long list of imports, some of them may fetch something into your scope, which made your code behave weird, because then your compiler treats some type as some other type because there is an implicit conversion in scope. Or maybe you are too eager with your imports, you import too much, and then again it's an ambiguous import, ambiguous implicit for the compiler because it can have more than one to put. So that's part of the problem, why for me Scala had definitely a steep learning curve. So now, how is it different in Scala 3? So Scala 3, as you probably already know, is kind of a major language rewrite. Not in terms of migration, but in terms of the concept in my mind. So actually, it took, I think, 8 years from the first commit to the general release of Scala 3. And what's most important for me, what's most significant, is that the creators and contributors, they have set on a mission to listen to us. So to see how Scala is being used, how libraries, how projects are written, what are our comments, what are our concerns, what are our questions. And they were on a mission to fix the tricky bits for us, to address the pain points and to make Scala a language which is easier and more convenient for everyday use. So by now it's probably not a surprise that implicits have been discovered as such a pain point, which was decided to be redesigned. And it's redesigned to the point where the implicit keyword is gone altogether. You don't really find it in Scala 3. So what do you get instead? Instead, you get a couple of new language features, and each of them does one thing and does it well. So let's see what those are. I will show you 7 pieces of code, 7 needs that I sometimes try to address, 7 issues, and we'll see Scala 2 versus Scala 3, how they compare. So that's the most important feature, providing context. The second one, we will add some functionality to types. Then we will show how to define type classes in Scala 3. I'll talk a bit about implicit conversions, and then we'll talk about imports, unused names, and compiler errors. Let's start with the most common and most important need, which is to provide context. So in Scala 2, if we want to have the code like below, this is really what we need. We want to define a future, and there's a body of the future. So that's what we want to write. However, we know that if it's some kind of asynchronous computation, it's not enough. So we need to have some kind of thread pool, or in this example, an execution context. So this is something that we may want to infer from the context and not just write explicitly in every future that we define. So the way you do it in Scala 2, if you take a look at the definition of the apply method of the future, apart from the first parameter list, it has another implicit parameter list, which defines that here you may provide this executor. And how do you provide it in your code? You just have an implicit value, and then you say execution context global is what we need, what we fetch, and we tell the compiler to just fetch it where it needs it. And by doing this, we can achieve what we want at the bottom, which is the clear definition of the future with just what should happen in the future. So that's Scala 2. We see the implicit keyword. How is it different in Scala 3? Here we want to achieve the same thing, so we want to have at the bottom the definition of the future with just the important parts for the reader. Now, if you look at the changed definition of the apply method in the future, you will see the new keyword. It's again a second parameter list, but here you have this using keyword. And in the place where you actually provide the execution context, you have a given. So instead of one implicit keyword, you get two new keywords. It's a pair, using and given. So where you define, you say that this method is going to use some context, in this case an executor, and where you provide, you are giving it. So this is the most important and most something that you will use the most in Scala 3 when working with contextual abstractions. So that's something to remember. But let's move on to adding functionality. Now, to describe it well, to explain it, let's imagine a sample domain. Let's say that we are working with providing social website for people who like to read books, so that you can add the books that you have read, you can add the books that you want to read, and there's also a thing called reading challenges, so that you may want to define at the beginning of the year that this year I'm gonna read 10 books or 20 books and see along the way if your goal is met. So that's all fine and it's working, but let's imagine our product owner comes to us and says that there's a problem because some of the users add really short books, like 5 pages long books, and they have these enormous reading challenges which they finish too early, and it's not so much fun. So we need to add a new method, this qualifies for challenge method. So what we would like to do is we would like to decide whether a given book qualifies for a challenge if it's longer than 20 pages. However, our problem is that our book type exists somewhere else in another package. It's a closed type, it belongs maybe to another team, it's imported from somewhere. We don't have control over it, and we cannot really add methods to it. But we would really like. So what can we do? Of course, with Scala you can achieve many things. So you can also add functionality to a closed type. And in Scala 2 you do it using an implicit class. So that's how you do it. You define it, you give it a name, even though it doesn't matter. It operates on the book type, and then it has this qualifies for challenge method. The definition of the method is that if the number of pages is greater than 20, then yes, the book does qualify. So again, we have the implicit keyword used for adding, in this case, for adding functionality to a closed type. Now let's see it in Scala 3. We want to achieve the same thing, so we want to have the code as below, which is just the same. We want to have this qualifies for challenge method, and at the top we have the closed type, so nothing changes here. But how do we achieve it in Scala 3? We have a new keyword. We have an extension keyword. And this is a good example of a thing which does one thing and does it well. So we have the extension defined on the type book. You define the qualifies for challenge method. You define the body. And as you see, the syntax is very simple. And the next time you see the extension keyword, you will probably instantly know what the author of the code is trying to achieve. They are trying to add some method to an otherwise closed type. The syntax is clear, so even maybe next time you won't need to go back to the docs, you will just write it from your memory. So that's an example of an improvement for the best, in my opinion. Let's now move on to something more complicated, type classes. So as I said, type classes are important in Scala and in some other languages. So why may we use it? Actually, it took me, I think, 5 years from my first writing Scala until I felt the need, okay, I need a type class here. So it's maybe not something you do on your first week writing in Scala, but it can happen. Let's imagine that we are still in our book website domain. We have books, and we have our reading challenge with a score. But it turns out some people come to us and they say, we don't really read such a lot of books, but we read a lot of articles on the internet or in magazines. And we would also like to take part in your challenges. But how do you compare? Reading 10 books and reading 10 articles is really something different. So let's imagine we want to add a scoring mechanism so that we would have a code like below, where let's say we have Dune, the book read, and then the current score, if we add this book, is 600. But then we can have an article type, a new article type, and if we add it, then it increases our score with a 1. So every article is counted as a 1. So how can we achieve the code like below? If the article and the book had a common parent, then maybe we could consider adding a method to this parent, maybe a trait, and then each of the classes would implement this trait with its own behavior. But it turns out that book and article are totally unrelated types in terms of type hierarchy. So again, we have no control over them. We cannot let them define and extend any traits, implement any traits, and so on. So for this, we might want to use type classes, because what we want to do is we want to add so-called ad hoc polymorphism. So give common behavior, define common behavior to unrelated types. And for this, we can use type classes. In Scala 2, the way we do it is we define a trait, and this is our behavior. In this case, it's our scorable behavior, parameterized by the t-type, and the behavior is to have this score method. And then we have, using implicit vals, or actually it can be implicit objects or defs, but here vals, you define the behaviors for each of the types. So we have the implicit val for the scorable behavior of the book type. And you see the implementation of the score method is the number of pages. And similarly, we have implemented the scorable behavior for the article type, where the score is always 1. And the way we could use it is here in this case class current score, where the add item method is parameterized by t::scorable. It's called context bounds. And it means that this is a method working on an item, on any item, any type which has the scorable behavior. And the way we use it if we are adding an item, we are taking the current value of the score, and with this implicitly of scorable, we are telling the compiler to fetch the right implementation of the behavior according to the type that we were called with. And if you don't like this implicitly of scorable, there's also another way to write it. You can have another parameter list. It may be something you prefer. There's an implicit parameter list where you have this scoring parameter named so that you can use it here in the scoring.score. It's just a named parameter. So that may be something you prefer. So that's how you do it in Scala 2. And that's why you may need type classes at all. And now in Scala 3, of course, you can also implement type classes. Our desired behavior is again at the bottom, nothing changes there. And the definition of the behavior, the trait, is also the same. And how do we implement this behavior? We use the given and using pair again here. So where we provide the behavior, the implementation of the behavior, we use the given keyword, and we have the scorable behavior for the book and the scorable behavior for the article implemented. And where we use it, again, we have context bounds, so that doesn't change. We are adding any item which has the scorable behavior. And then instead of the implicitly keyword, we now have a new summon keyword. So even for such a small thing, this has changed. The implicit keyword is not part of the implicitly keyword because this doesn't exist either. So we have this summon keyword. So we tell the compiler to summon the correct implementation of the behavior that we want to use. And also, we can have consistently the other way of defining that. So that's with an implicit parameter list. But here you will have this using keyword. And again, you can call the method on your scoring item. So that's how type classes look in Scala 3. Now let's move on to implicit conversions. Why we may want to use implicit conversions? Maybe they're kind of controversial because of the problems I mentioned earlier, that sometimes it's a bit too implicit, that the compiler treats one type as the other type. But let's say we need it. Let's say we have our book type, and we would like to print it. And we have this print method defined at the top. It's this beautiful and special way of printing that we would like to use. But there's one problem. This print method operates on an item type, and we are working with book type. And again, the item type is closed, the print method is closed, and we would like to somehow overcome this. So what do? In Scala 2, we can define an implicit conversion with an implicit method. So we call it book to item, whatever name. It operates on the book type and returns the item type. And the definition of the method is just to use the constructor. And if we have such an implicit in scope, then the code at the bottom compiles. So we can have the print method, the compiler knows how to treat book as an item. And how do we achieve that in Scala 3? Again, the code at the bottom and at the top is the same. But to provide the conversion, there is a special Scala.conversion class that you need to extend. It's a class defined just for that. It's parameterized by the source and the target type, so in our case, book and item type. And then the apply method applies the conversion for you. And the definition, the body of the method, again, is the constructor. So again, here, this is a thing which does one thing and does it well. So whenever you see the Scala.conversion class in your code, you instantly know that it's an implicit conversion. It's not anything else. So in Scala 3, it's almost as it makes implicit conversion a bit more explicit. So that makes it less confusing. And now if we're talking about confusion, let's talk about imports. So my nemesis of trying to find or guess the right import. In Scala 2, such a code would compile and work just fine. We are importing everything asterisk from this package or object, and then our future compiles. But in Scala 3, this would give you an error, the same code. And that's because in Scala 3, asterisk means import everything apart from given instances. So import only the explicit stuff. And if you do want to import the given instances, you need to use the .given syntax. So that makes it a bit more explicit in the long list of imports, which imports actually import some givens for you. So it makes it easier to find. And if you do want to import really everything, then you can use this given, asterisk syntax, and then you really import everything. But you see it, you see instantly what happens here. And now there are also unused names. So this is one of my favorites because it's a really small improvement to the language, but it makes everyday life so much easier. So in Scala 2, the names of the implicits were mandatory. Let's imagine we have our books, we have a sequence of books, and we would like to sort them. So in order to not reinvent the wheel, we are using the CCOP trait with the sorted method, because we want to use it like below. But if you see at the top, there is this implicit parameter list with the implicit ordering, because we need to tell the compiler how we want to order the books. Is it according to the name, according to the number of pages, or something like that? And in Scala 2, you again use the implicit value, and you say that this is your ordering parameterized by the book, so this is your ordering of books, and the implementation is for 2 books, we just compare the titles. So you need to think of this by title name, but if you see below, we are not using it really, right? Because for the compiler, it's enough to see the types. If it has the implicit with the correct types, it will just use it where it needs such types. But still, we have to think of this. And in Scala 3, we are using the using and given pair again, and we can provide the name of the val, but we don't have to. So we also can have the syntax like below. And this is all we need. This is all the compiler needs, because it knows that we are providing an ordering for books with such a definition. And we also maybe don't need it. So then the decision is ours. Do we want to give it a meaningful name? Or do we want to omit it? This is just one more decision that you are making in your everyday coding. And naming things is hard, so why lose brain cycles for that? You can just omit it. But if you want, you can say that this is your meaningful name that you provide. And you could see it also in the previous examples that some of the names had to be provided even though they were not used by the compiler. And if we are talking about compiler, let's also talk about compiler errors. So in my quest to find the right import, in Scala 2, the compiler was trying to be useful, but not too much. If you see the error message here, it says, could not find implicit value for evidence parameter of some type. So I know what is missing, but where? And sometimes it's easy, but sometimes if you have a long chain of method calls, you really don't know which one needs the import. And I know that there is a shortcut in my IDE which tells me, shows me implicit needed stuff, but I never remember that shortcut. And if I go to the internet to find the right shortcut, I'm already distracted and I don't know what I was doing in the first place. So this is again a small thing that you trip over in your everyday writing Scala life. And in Scala 3, the compiler error is much more helpful. So it says no implicit argument of type scorable was found for parameter scoring of method add item in class current score. So we know which class, which method, which parameter. So that makes it much more easier. And sometimes the compiler will try to be even more helpful. So it might suggest some imports for you. And sometimes it's not what you want. But sometimes when you're hacking away, you are in a hurry, you just want to make it compile, you are writing an MVP, yes, it's okay for you. Just use the default implicits.global here in this test or in this, I don't know, throwaway code that you are writing just to prove something. So that's a small thing, a small help which makes your daily Scala writing a bit easier. So that were the 7 examples. And now, how do we go about migration? Because when I said it's a major language rewrite, then does the migration also happen to be major? And if I say that the implicit keyword is gone, then do we need to make a big bang rewrite, which means we will never do it because it's not worth it? Actually, it's a bit more easier. So in general, Scala 3 is somehow backwards compatible. So a lot of your Scala 2 code will compile in Scala 3. And there are also some compiler flags which let you tweak how much you want to rewrite and some automatic rewritings. But in terms of implicits, I said they were gone, but actually you still can use them. So you may, for example, have your code fully migrated to the using and given, but what about the libraries? You can use the libraries which still use the implicit keyword with your migrated code. Or maybe your code uses implicits, but you are trying to use a new library with the given and using pair. So you can do it interchangeably. The compiler will translate it for you, so you can use both at the same time, and you can perform the migration on your own pace, just switching from implicits to given and using to the new implicit conversions and so on. So in theory, you don't really need to get rid of your implicits. But why stick with the old ways if we have the new features which make your code more easier to read, actually easier to reason about, which is what we love about Scala. So that's this interoperability, which makes you do the migration at your own pace. And probably sometime in the future, the implicit keyword will be deprecated. I am not sure when. I haven't found such an information. I also hear people who say it will never be deprecated because it's such a core feature of the language. We'll see. But for now, nothing stops you from using the implicits or using the new, nice, shiny things that we have. So to sum up, what I love most about contextual abstractions in Scala 3, although it's hard to love implicits and the complicated stuff, is that they let you write the intention. I like to think of writing a code as I'm writing a book, I'm writing a story, and then someone else comes and reads it. And then they know what my goal is, what I'm trying to achieve here, and not how I am trying to achieve it, and what language features I am using. So this is something that I love about the implicits in Scala 3, is that they let me write what I want to write. So I think that's also, in my mind, consistent with the functional programming being a bit more about writing what and not writing how. So the given using pair is something that you will use most often, but other tools and features in your toolbox are now the extension methods, so a special keyword just for that, and the Scala.conversion class, which is used to convert between the types. If you'd like to know more, there's also a feature called context functions, which I haven't mentioned because it's a feature of Scala 3 which doesn't have a direct counterpart in Scala 2. So that's something new which you might want to have a look at. If you'd like to see the docs, the reference, you will see all the small print about what will compile, what won't compile, what you have to fix right now, what you can fix later. And also with the migration guide. And here are the two repositories of the codes from this presentation. If you'd like to play with them, see how the compiler behaves, you can have a look. So that's all I had. If you have any questions, I think we will have time for that. If you have any comments or feedback, I am waiting for that under this QR code and under this bit.ly link. And one more thing is, at Software Mill, we are organizing the Scala conference in March next year, but also a new Rust conference. If you're interested, you can use the Magda 10 code to have 10% of the ticket. So thank you. Are there any questions?
Yeah, hello. Yeah. First of all, if we want to talk, I had a question about one of the inputs. So in Scala 3, launch that correctly, all given definitions, or like implicit definitions, are imported with the .given. But then for the execution context, you imported .global. I'm just confused.
Oh, sorry. That's this implicit.global that we saw there is just the name of the given instance in that package. So I actually imported directly the one given instance that I needed.
Okay. Okay. Thank you.
Thank you for the question.
Thank you for the comments. What if you want to specifically import a given that you define without a name? Is that possible?
That's a good question. I know that those givens are given a default name which you can use, but in my mind that would be a bit confusing. So it depends. If you control it, you may want to give it a name actually so that it's easier to import, or you can use the automatically generated name, or you can just use the .given to import all of them.
I think you can also import by type.
Well, what can I import?
If you have a given for ordering, you can import it. Import something that ordering by type. So even if it's unnamed.
I'm not sure what that is. So that I import the ordering, and then what is the problem? I'm not sure what backtyping is.
If you have like given order column ordering in some package, then you can import that package that order by type.
Yes.
So.
Okay. Maybe if someone knows a better answer than me, then we can say that out loud.
Just to make sure that I understood correctly, what we're saying is that if you have an anonymous given value, you can import it instead of referring to the auto-generated name, importing it by putting the type of the implicit value, and that will import the given, even if it doesn't have any. You can just use the value with the type referred to it. Is that what you meant?
You mean in the import line to use the type?
If you have an anonymous given, you can just use, yeah, that's what I understood.
I don't know. I don't know. Does anyone know? Can we do it?
Yes, I propose the fact that you can do it.
Okay, good. So now we know it does exist, but we would need to check how it looks like. Thank you for the question.
Thank you very much.
Thank you. Do I switch off?
Some engineering.
That's what the skill of the language means that to me. Yeah. I mean, there's no playing to that. I'm probably going to, yeah, I'm probably going to I would like to see, probably doing more than this one myself. This would probably involve some, involve a lot more preparation than case. I would like 10,000-foot view of the Atlantis, but most of it started on the discussion of where the skull, what kind of development, or what kind of structure the skull was part of. Because so far, the skull has been a project that has these new features with these clear mindset that I was talking about, but it has a very disparate objective, which doesn't really have a target. Because of that, skull has been out there for several years now, during which time the likes of Java and Kotlin have come to new features for Scala, and they brought it to their own ecosystem that are looking for Scala, and Scala is left with less and less as time moves on, because I don't think that Scala is great target. So my main value of Scala is that it allows me to think not just for choosing sake, but for productivity. And that means that we can ship products. That's what I want to talk about. So I think that's the goal of this presentation. I'm not sure how well I'm going to deliver this point, but at least I want to start a conversation, and I want to where others not read it towards more clarity over where Scala or what kind of things we want to work. Because we say that Scala is general everything. If your target is everything, then target
Mais par contre, il faudrait qu'on soit vraiment, c'est composé.
Je vais quand même essayer.
Moi j'avais fini par trouver un post sur un forum qui disait ouais mais non.
Ah ouais non ça marche pas quand même.
C'est une limitation de Sony.
Tu vois réglage PC à distance.
Ouais.
Et là t'es à PC uniquement et tu peux mettre PC caméra. Ah oui mais c'est destination enregistrement image fixe.
Ouais. Oui.
Donc ça a peut-être rien à voir.
PC et caméra, c'est quand tu te mets en tethering, c'est quand tu fais shooting photo.
Ah ouais. Oui donc en effet.
Ça c'est bien quand tu branches un câble USB-C. En fait, c'est ça. C'est dès que je prends une source en 60p, je comprends pas. C'est complètement aléatoire. On a, non, ça va marcher avec le tir nickel. Et là, avec celui-là.
Yeah, I don't know. I mean, listen, yeah, I know. So, wait, what did you say?
Ah, un poste de stream.
Je sais pas, j'en ai, ouais.
Hey everyone, thank you for coming to my talk. I'm going to talk about Scala and tools for product development, or tools for Scala startups. Quick question for you. How many of you have heard about Rock the JVM? Can you raise your hands? Beautiful. Thank you so much for following my work. For anyone who was watching this on another platform, maybe on YouTube or something, my name is Daniel Ciocărlan. I'm a Romanian software engineer, and I created this website called Rock the JVM, where I teach pretty much everything in the Scala ecosystem, including various tools and libraries and techniques for functional programming and product development. My courses have reached more than 100,000 people all over the world, and I've also had the privilege of training high-performance teams at some big names that you may have heard about, including Adobe, Apple, and other big companies. And my website is rockthejvm.com, where you can find pretty much everything that I've put out. I've recorded hundreds of hours of video courses and compressed lessons on the best practices in functional programming and in the Scala ecosystem. And you can find my work at rockthejvm.com. You can email me at that email, daniel@rockthejvm.com, for pretty much anything about Scala. You can find me at rockthejvm.com on Twitter and LinkedIn LinkedIn and Reddit and YouTube and pretty much all socials. All right. So I'm going to talk about startups, and I'm going to talk about product development in particular, because startup is a very loaded term. So I'm going to talk about mostly products. And the question is, why would you build a startup? A startup means different things to different people. And so I would categorize startups depending on the objective that you set for yourself. A startup may mean a single product that you've built as a single person. A startup may mean a unicorn that it wants to reach out millions and billions of people, reach out to IPOs and stuff, and make trillions of dollars and make you a gazillionaire. So startup can mean different things. But some reasons that resonate with me include something like this: to build a product that you can be proud of, build a product as a single developer, or create a lifestyle business that is sustainable and gets you a decent income, enough to free up your time to spend the time on the activities that you like, or learn some skills that you would have liked but never had the time for, or speak at conferences, or enjoyable things like that, or to make something sustainable as a product, either by yourself or as a small team. So you can have this sort of camaraderie where you can reach out to 2 or 3 of your friends and build a product that serves a decent amount of people and has a minimal impact on the world. Or if you want to build a rocket ship that scales up to billions of people and makes trillions of dollars, you can also do that. So this is one potential reason why I would build what I call a startup, depending on the kind of objective that you set for yourself. Now, in order to build something that's technical, so a startup in the sense of a digital product or software system, you have at your disposal a variety of tools and technologies, mostly in the Python ecosystem, mostly in the JavaScript ecosystem, and maybe some other languages like in Rails or in TypeScript or in Java, like you have Spring and stuff. I would argue that Scala is well suited for startups at any scale, which is why I would put Scala on top of pretty much everything else, because it's such a productive language. So you can build your own products with Scala for any scale and for any purpose. This is what I would like to talk about in this presentation, and primarily what I want to talk about is some tools that you can use as a software engineer to build products at any scale, and also what we can do to target Scala as a language for product development, not necessarily a language for, or not necessarily only as a language for software engineering and computer science research. All right, so I'm going to talk about tools that you can use as a software engineer, and then I'm going to, hopefully, by the end of this presentation, start a conversation of what it means to be productive as a software engineer and how we can leverage Scala as the ultimate tool to doing that. So why would you build a Scala startup? Well, it means to me that Scala is a truly scalable language because you can stay in the same ecosystem regardless of whether you're building a one-line script or whether you're building a million lines of code, building something that's, that serves millions of people or processes exabytes of data at scale or whatever you have. So you can ship an MVP, but still stay in the same ecosystem because you can iterate and expand your code as necessary. Scala is, as I'm pretty sure you can attest on your own experience, that's I'm guessing why you're here, is because of your love for Scala, because it's so beautiful, it's so concise, it's so expressive, it's so powerful, and its type safety is almost unparalleled. And it allows you to do a lot of productivity with very little code and with very little let's say, labor in terms of code that you have to write. And so Scala is, in my opinion, a very powerful tool, very underrated for product development in a full stack setting. And full stack because Scala is also multi-platform in the sense that you can build backend systems, which I'm pretty sure most of you have experience with, but you can also build front ends, and you can build very scalable front ends by leveraging very simple principles that you can expand in reactive UIs. And it's also been battle tested in very big systems all over the world, including Twitter and Disney and Databricks, and we have many examples of various tools that have proven themselves in production. So can Scala do it? My answer is a resounding yes. And the caveat to that is that you need to know the lay of the land, which is one of the goals of this presentation. So in terms of a Scala tech stack, we have some things to keep in mind in order to build a powerful and an effective tech stack. So what makes a good tech stack? First of all, you need to be able to have the entire tech stack in your head, which is something that very few libraries in the Scala world have managed to do, or they have managed to do only to very experienced engineers. So if you're someone very experienced with, for example, the type level stack, you can have the entire tech stack in your head, but only after several years of experience. One of my jobs at Rock.jvm has been to lower down that learning curve and make the core principles easy to remember and easy to keep in your mind. So ideally, you should be able to work on a plane with no internet connection. That's before Elon Musk can get Starlinks on every plane. To work in a plane with just the documentation of the code of the library and still be able to write your code as you have no internet connection or no ChatGPT or no Googles or no Stack Overflows. So if you have the entire framework in your head, I see that as a sign of success. Then a tech stack needs to be performant because no full stack product is ever going to be useful unless it moves quite quickly. It also needs to be scalable in order for us to build products for a variety of audiences and for small or big user bases. Then we need to have something that's, let's say, underserved in pretty much all of software development, really, which is the ease of deployment. There have been many attempts at simplifying deployment and shipping products, and Scala is no stranger to the, let's say, the overhead in managing scripts and deployment stuff that we need to manage ourselves. And so if you have a good tech stack, you should be able to do like a Control-K or Control-Shift KW or whatever, and it should like push to production. I'm not sure why you would need anything more complicated than that. And obviously the developer experience is something that is going to help us a lot, because I'm seeing no objective reason why Scala couldn't be able, a skilled Scala developer couldn't be able to ship a full-blown, full-stack product with like credit card checkout and stuff in 3 days or in 3 hours, for that matter. So the dev experience needs to be conducive to that sort of experience. And obviously, we have some additional things that will make a tech stack usable and friendly, which means the compatibility with other tools so that you can integrate yourself very easily, and also the ecosystem maturity and community support, which allows us to solve each other's problems and help each other along the way. Now, for me, I am a solo engineer. So I'm building products for myself, so I don't care about best practices, although I happen to have good knowledge over them. I will pick the best practice for me because I'm the one writing the code, I'm the one reading it later, and I'm the one who's going to maintain them. So if you're a solo developer, my advice is just to make up your own best practice so that you don't hit yourself in the head later. If you're a small team, again, you need to make your own best practice by talking to each other and filling up each other's gaps. And only if you're a big team, or if you need to introduce process along the way, only then it's worth establishing something more, let's say, elaborate or something more process-oriented. Now, in what I'm going to talk about next, I'm going to outline some tech stacks and some tools for product development that will help you build Scala products if you combine them together. With a caveat and with a disclaimer that I am a complete ignorant about the state of many libraries and tools, you're probably going to ask, what about this library? What about that library? You haven't talked about that. I will very much like to know about that. So I'm about to show you some things that work for me. I'm pretty sure there are some very useful tools out there, and I want to know about them. And you should also do your best to speak about them at conferences like this, or on, I don't know, in blog posts or in YouTube channels. I'm personally offering my own YouTube channel to help evangelize your library or your tool if you need. So if you have this sort of request, I'm more than happy to offer my own channel to do that. Now, what I will also say is that Scala is an extremely underrated language, which is probably what you've also seen. Compared to the likes of JavaScript or Python, Scala is super underrated. And if you have, for example, let's say 5% or 10% of the workload and of the, let's say, dev time invested into Scala compared to the dev time in JavaScript, Scala would probably destroy them outright. I'm going to talk about some tools and some tech stacks that worked for me, and you can pick and choose whatever you find most suitable for your own mindset. Okay, so the first backend Scala tool that I'm going to talk about is the Akka or Peko stack. You probably have experience with Akka. It's one of the oldest toolkits in the true sense of the word, and it involves the actor model that has proven itself in production many, many times and over many years. Now, obviously, Akka has changed their license to something business-oriented, which is why we have this Peko thing, which is just as good as Akka, and it's also an Apache top-level project, which means that it has good support, it has good maintenance, it has active contributions, and it has great interoperability with other tools or other stacks, for example, Akka or Cassandra or Postgres or things of that sort. So if you want to use this sort of stack, this is the kind of combination that I would personally use. I'm working on a product right now, and I'm going to use Peko for it, which involves Peko HTTP for a nice DSL to create web services or microservices, Peko Streams for data flow, and Peko Streams has this very nice graph DSL that allows you to see your data flow almost visually. It's like an ASCII art that compiles in Scala. Then we have, for storage, Peko Persistence and this CQRS pattern, which allows you to separate the act of emission of commands from the act of reading events, which is far more useful to the user to understand, not necessarily in terms of the clicks that they used in the application. And for scalability, if you have a single service or a business logic that cannot really stay on the same machine, there's also the option of clustering that, which is a very powerful tool. And if you want microservices to talk to each other, you have Peko gRPC. And we have other libraries like Peko interacting with Kafka or Postgres or Cassandra or other kinds of services. Now, Akka or Peko, this stack, is best used for the systems that are based on events. So maybe something that tracks orders in an e-commerce store or in my little product that may, or, by the way, it may or may not see the light of day. I don't know, but if it's good, you're probably going to hear about it with I don't know, something authenticated or some user data capture or new data arriving in a system or something like that. So Peko is very useful for systems that are based on events, and you can obtain scalability by multiplying instances of the same type. For example, you can multiply a little microservice, or you can multiply even a single core of business logic with clustering. So that's one tech stack. Another tech stack is the Zio stack. Some of the talks here today have touched upon Zio at least. And Zio is, I'm pretty sure you know, this is an effect system that uses pure functional programming, and it's also been proven in production. If you were to choose the Zio stack, this is the kind of library combination that I would use. Zio HTTP with Zio JSON. If you want to use GraphQL, there's Caliban for doing that. It's an amazing little library. For data flows, we have ZIO streams. For business logic, we have arbitrary effects described as core ZIO data types. Then we have, for storage, we have Quill and the new library Magnum. There's also a form of ZIO SQL. And pretty much for everything else, ZIO has an increasingly rich ecosystem of libraries that can interact ZIO with various other services like ZIO Kafka, ZIO whatever. And if you wanted to use the stack, I would pick ZIO for type safety and for effect-based backend systems, and for bringing or for purifying other Java code and bringing them into the same ecosystem. So that's the ZIO stack. Obviously, we have the type level stack as well. These are two equivalent ecosystems. Type level is a little bit more general and a little bit more mathematical in that sense. So the type level stack is based on Cat's effect, and this is the effect system with pure functional programming as well. This has had the chance over the years to be proven in slightly bigger systems like Disney streaming. And if you were to choose this stack, these are the libraries that I will use. HTTP4S, which even though HTTP4S is at 0.37 for the past 5 years. It has proven them in production many, many times over, so it might as well be a good 1.0. We have FS2, and we have some fans here for FS2 that can treat data flows easily. For the business logic, we have various effect systems that you can plug in. Cat's effect is obviously the core choice, but you also have Monix, or you can even plug in the ZIO scheduler, the ZIO type in the type level stack, as well as you use the so-called tagless final. And for everything else, you can purify other Java libraries, or you can have other libraries in the type level ecosystem for building various use cases. This is best for bigger projects if you want to have something that uses I don't know, something more critical, or a banking system, or a streaming service where a lot of people would lose a lot of money if the system went down. Then you would use something like this. And if you want to keep the code mathematically provably correct, you would use something like this. Now, this is a new slide that I've added this morning because we have had a talk with Kio. So Kio is this new effect system with direct style toolkit. Kio is still in active development, so I can't really recommend it for production use cases at the moment. But it's great for experimental projects, and you can use for web services. We have Kio Tapir and Kio Caliban. If you want to use GraphQL, you have Kio Core or the Kio algebraic, I forget what it's called. It's Kio Prelude, right? Kio Prelude for functional programming. And the tight integration with ZIO gives it access to the ZIO ecosystem, which is going to make it potentially great for backend systems. So these are library stacks. Then we have full frameworks. Has anyone forgotten about Play? So Play Framework has been one of the oldest and still in active development true Scala frameworks. So it's a framework in the true sense of the word because we have batteries included. So there's very little that you need to integrate with Play Framework. You can simply use the business logic in core Scala, or if you want, you can use Akka or Pecco because Play Framework is built with Akka or Pecco. So Play supports Scala 3. It's still in active development, and it's great for building scalable web applications. And I personally know institutions that are using Play Framework. I recently did a training session for a group of Scala developers that would work for HMRC in the UK. So the HMRC tax system in the UK, at least the web application for submitting tax returns, is based on Play Framework. So it's great for creating stable and robust web applications, especially if you want to scale out. And then we have Howie. Is Howie in the room? No. So Howie is great. Howie is one of the Scala engineers in the community that I respect the most because he single-handedly has an entire stack for building Scala applications of any shape and size. So with pure Scala, you can build pretty much anything with his libraries. And one reason why I respect Howie so much is because he also has his own skin in the game. He uses his own libraries to build his own products. He worked at Databricks for a while. I'm pretty sure he used some of these libraries there as well. He created his own book. I might be wrong about this, but I'm pretty sure that he published his own book with the libraries that I'm showing here. So we have Cask, Scala tags. You can also do server-side rendering. You can do Scala JS with his libraries. So you can pretty much build a full-blown Scala product with some of Howie's libraries. This is great for solo developers or people jumping into Scala, because you don't need that complicated, let's say, notions about effect systems or advanced functional programming, higher kind of types, implicits, or whatever. You can get started building products very quickly. So these are some of the stacks for backend. Some of these tools also have libraries compiled for frontend. Speaking of which, Scala JS is great. We should talk more at JavaScript conferences about Scala JS. Even though we compile the JavaScript binaries to like megabytes in size, which is probably going to make JavaScript developers sneer at us, the thinking model behind reactive libraries and behind reactive web applications in Scala JS make it very easy for us to build highly scalable UIs. And the two libraries that I personally used for my own products are Tyrian and Laminar. Has anyone heard about Tyrian? Can you raise your hands? Okay, so Tyrian is a great Scala JS library that has the architecture inspired by Elm. And this is based on Cat's effect, and it has pure functional programming. And you can learn that in 1.5 hours. You can get all the principles of Tyrian, and then you can write reactive web applications with all the concepts that you need. So it works best with a type level stack. I personally teach this in my giant type level rite of passage course, and it works great for reactive web applications. The other one is Laminar. How many of you have heard about Laminar? All right, a little bit more. So Laminar is a functional reactive programming UI library, and it works with pretty much any backend stack. Again, Nikita, who wrote Laminar, is a developer that I respect a lot, because with just 2 libraries and with maybe 2 hours of learning time, you can create arbitrarily complex web applications with Scala JS. And Scala JS is great because it's extremely stable, and it allows us to interact with the JavaScript ecosystem. So much the same in the same style as regular Scala can leverage the JVM ecosystem, Scala JS can leverage the JavaScript ecosystem. And we have tools for interacting with the TypeScript ecosystem. I think we're going to hear Olivier talking later about his scaffolding with the Zio full stack application. And he used scalably typed to use a TypeScript library, and very easily so with Scala JS. Now, we have back-end Scala tools, we have front-end Scala tools, and that is strictly for software development, for like writing code. But we also have other tools that are going to be very helpful for us to build and ship our code. For me, as a solo developer, I shouldn't really care about build systems, DevOps, and things like that. Ideally, these build systems would allow me to hit a command like Control-Shift something and just push the code to a branch and then deploy to production in another click if that thing works well. So we have many definition libraries for cross-platform development. So sharing code between front-end and back-end is one of the, let's say, unsung heroes in Scala full-stack development. And it's an extremely underrated feature that will help developers free up their mental space a lot. For example, if you're trying to do a full-stack web application with Spring and then React on the front end, you'll need to do type definitions on TypeScript or something so that you can use the services in React. And then you'll have to rebuild these things whenever you change your data model. With Scala, you don't need to do that. So with these definition libraries like Tapir and Smithy4S and various other libraries for data definition, you don't have to rebuild your data model between the backend and the front end. We can consider Scala as a completely full-stack language, which I think is completely underrated and would help accelerate the development of full stack products. Then we have build systems like SBT and MIL. Again, we have to thank Eugene for essentially holding 3/4 of all Scala products on his shoulders by developing SBT. So huge claps to Eugene for doing that. Most of the rest goes to Howie for developing the MIL system, and we have Jamie to talk about the porting of MIL to Scala 3, which is absolutely fantastic. I'm looking forward to doing that. So these build systems are super powerful, and it would be great if they allowed us to develop really short commands to push and deploy our code. Then we have dev tools like Metals and IntelliJ, which have been improving over time. With Scala 3, we have increasing support for various language features and increasing the dev experience. And we have various things that I really don't want to talk about. I know very little about deployment. Ideally, I would prefer to ship my code to a regular VPS like DigitalOcean and stuff and not care about pretty much anything else. But you have these at your disposal, and it would be great to have tools or libraries that would push to these systems automatically. All right, so this is a disclaimer. If you know your own tool that works better, I would very much like to know about it. Like I said, I'm ignorant about anything that I haven't tried, so this thing may very easily hold true. Now, I've talked about various tools and various library stacks that work well in a full stack setting. But they're mostly library stacks. We only have Play Framework as a full framework for building applications. So the question is, where are the rest of the Scala frameworks? Because Scala is so powerful that it allows us to perform any sort of task. And it's very powerful in the sense that you can build arbitrarily large applications. So where are the frameworks for doing that? That's a question that I will talk about and expand later, but this is just food for thought. Now, I've talked about software development, writing code, and maybe building and deploying your code to production. It would be absolutely great if we could somehow integrate these tighter, and I'm personally going to help test this on my own with my own products and maybe share my lessons along the way so that we can have let's say, a shortcut to building Scala products quickly in like a day or two, rather than in a month or two. Now, speaking about the tools for software development, it's not just about writing code, but integrating with other services, because a startup is not just the product implementation or the code that you write and that you push to production, and congratulations, you have your own JVM application at 172.55.42.1. You need to integrate yourself with other products to be a useful thing for the world. And so you need to be able to integrate your own product with other tools. For example, analytics or alerting or emails or AI or community support or customer service. These are all important components of a successful startup, and for now, we need to essentially write our own tools to be able to integrate to these, or hack our way through integrating maybe a Scala.js script that does social proof and integrates intercom as a little bubble here in your front-end application. But it's mostly hacked. And so it would be great if we had better tools or a tighter integration with some of these services so that we can deploy products that are immediately useful by leveraging these other services. Now, speaking about the dev cycle, this is also something that we could potentially improve. Ideally, we would have the development cycle fun. And Scala is plenty fun on its own right. It's a beautiful language. It's very expressive. It's very powerful. But what about the dev cycle and the developer experience? Because we get errors. We get compiling things that don't work our way. We have very cryptic errors sometimes. So it would be very cool if we could iterate our products very quickly and get errors and get instructions on how to solve them very clearly so that we can progress effects on our code. So the goal for a good toolkit would be something like this, to offer clear errors, to offer easy deployment, speaking of build systems, integrate easily with other services. So these are all areas where especially build systems could potentially help in creating products very quickly. Now, speaking of the dev cycle, I like to think about the dev cycle as something that we don't necessarily do over a weekend, but something that we do continuously for years or maybe our entire careers. So it's not a thing that you do once, but developing a product or the mindset of developing a product is something that's habitual. It's a habit. And so like any habit, I like to think about habits in terms of this little book that was a cornerstone for how I personally organize my own habits. It's called Atomic Habits. And the 4 critical tenets of creating a good habit, or the opposites of that, breaking a bad habit, would be to make the activity obvious, make it attractive, make it easy, and make it satisfying. If you maximize these 4 metrics, the habit loop becomes effortless and becomes very cool, very fun, and very easy to repeat. It brings a virtuous cycle. And specifically about the dev cycle, if we could create a toolkit that would enforce, or rather encourage, these tenets, we would have a really cool dev cycle and would make adoption of Scala really easy. Now, concretely, what does that mean? In terms of make it obvious, if you could build a toolkit or a framework that makes it super clear what you're allowed to do where and where you should put your code, that would very much relieve mental burden in terms of decision making. If you can make it attractive, the vision of your product needs to be compelling. So you'd be able to, if you are somehow able to describe your vision of your product in code very easily, so that the framework can guide you over where you need to add your code, that would be absolutely fantastic. Scala does most of the job in tenet number 3, which makes it easy because if you know even a minimum of Scala, you can translate your thoughts very easily into succinct code. So you can do a lot with very little code. But in terms of tools for product development, it would be absolutely fantastic if we could make local iteration and the building of a testable product very easy. So maybe a shortcut or something that would trigger an SBT build so that we can ship to a branch or ship to a staging environment so that we can test our product. And finally, make it satisfying. The code is mostly beautiful in Scala, unless you write Java code with Scala syntax, which all of us are trying to avoid. But the satisfying part is knowing that a product is great and also that the code is beautiful on the inside. It's like building a Mac, right? So we have Steve Jobs, very famous for saying that a good a well-engineered product should be beautiful on the outside, and it should be beautiful on the inside too. So when you open the screws in a Mac, it's absolutely impeccable. So it would be absolutely fantastic if we could do something like that for Scala as well. Now, finally, if you were to build a startup or a product, the most important thing is not necessarily the code. It's picking the relevant problems to solve. So as much as possible, try to be useful and solving pain points that you hear about it, starting with your own. So this is what I am personally trying to do over the next span of time, and I'm going to help as much as I can move the needle in that direction. So at this point, I've talked about tools for product development, but you may be wondering what's the point of that? One of the points was to create a 10,000 view over the land of libraries, and I'm very open to hearing suggestions of other tools that you found useful. But primarily for this talk, I wanted to start a conversation because Scala is an incredibly powerful language. It's an incredibly powerful toolkit. And it's not just for building distributed systems that have worked at the scales of Twitter and Databricks and PayPal and whatever else Scala has managed to build, but it's a very powerful language for building simple and then expandable products quickly. So far, Scala has not, at least in my mind, has had this, this objective as a target, but my question to you and my question to this conversation would be, what do we want Scala to be? Do we want Scala to be this research language that in 3 years' time, Java is going to start stealing features from? Or do we want Scala to be a product language that would help rival the JavaScript frameworks and build products in a day instead of a week? All right. So this is the kind of conversation that I want to start. I hope I was at least giving some food for thought. And speaking of Scala products, we have a workshop tomorrow, and I invite all of you to join. We're going to build a full stack product live, almost from scratch. And by the end of the workshop tomorrow, we're going to have something deployed with credit card checkout, hopefully. So somebody can pay for the product that we're building. Hopefully I can do that in like 5 hours. We'll see. So I invite everyone to join the workshop tomorrow. I am more than happy to have you there. Scala is a great language, and I'm pretty sure that you agree. If you have any questions, I'm more than happy to help answer them. You can find my work at Rock the JVM. Thank you so much. Going once.
Thank you, Costa. And this morning there was the idea that there are many ways of doing Scala, and you showed a number of them. Do you think it's a problem to have so many ways of building stacks on Scala?
I think I see these alternative stacks as I don't think that this is a bad thing. So as Valentin was saying in the beginning, look at the JavaScript frameworks. So you have like React and Astra and Svelte and Vue and whatever. So there are many ways of doing the same thing, but they're not necessarily ways of doing the same thing, but rather different mindsets, different approaches, different mental models. And I view that as great because these mental models are not easily transferable to other ecosystems. So I think it's great, and I think it's creating rather a moat around Scala as something that differentiates Scala compared to other languages.
Question? Thank you very much.
Thank you so much. Can I take this?
Sure.
Hello. A quick update on the community party. So we held at the restaurant Lajda near Torberg, the station. We sent an email and posted something on Twitter about it. It will be at 7:30 tonight. And please welcome.
My very good friend.
Please welcome Roberto Talley. We'll talk about us about joint food and secure application to manage, etc. Sorry.
Cheers, thank you very much. Well, if you're here, you're probably here because you want to share libraries, or at least you're thinking about it, and that's good because we should share. I mean, the world is better if we share, and it's obviously much better for the Scala ecosystem if we share our code as well, right? So sharing libraries is a wonderful thing to do. At The Guardian, we have a lot of libraries. We have about 40 of them, and we don't have a monorepo. So this is actually kind of how our different teams, our dozens of different teams, expose their functionality to other teams. So they have APIs, and they have clients for talking to those APIs. Those are given as libraries. We also have shared infrastructure and security code, and we also have just common general code that is kind of cool and useful and generally useful to the outside world. So we publish quite a lot of open source libraries as well. So we've been doing that for a long time. Last year in 2023, we've been doing it for a decade. We've been publishing to Maven Central because it is like the de facto place to publish artifacts to. And the Maven Central is run by Sonatype, who give you a server to push your artifacts to called oss.sonatype.org. And this whole arrangement is kind of free for open source projects. It was really nice. We don't have to run our own artifact repository. But on the other hand, it can be quite slow publishing things into Maven Central. And in fact, last year, after having been doing this for 10 years, there was still two quite significant problems, which was that it was both difficult and dangerous, which is two pretty major problems to have with the way you work. So the reason it was difficult was because to push to Maven Central, to push to oss.sonatype.org, you need a quite complicated set of credentials. You need credentials with Sonatype. You get those authorized to push to your Maven coordinate by opening a ticket in Jira, which is eventually answered by a human being. And as well as those Sonatype credentials, you also need PGP credentials to sign all the artifacts you put up. That's one of the requirements of Maven Central. And that's all sort of reasonable, but actually, when a developer's working on a team and they suddenly need to like upgrade a library, it's quite likely that they haven't even heard of PGP. That's normal for a lot of developers. I've not heard of it. And setting up a PGP key is a pain. You have to publish it to a key server if you can find a working one. It's a drag. And then the actual, the process that we were more or less commonly using across The Guardian for publishing was using SBT release, which is a nice plugin, running on developer laptops. So that is like quite a manual process, and there is a certain like uncontrolled nature to developers' laptops. They install all sorts of software that they're not necessarily the most controlled environment. And some teams have been looking at trying to address this by using automated CI release, right? And the sort of individual teams have been kind of experimenting on this, but there was no standardized way of doing it. And a lot of people were creating like quite large YAML scripts that could do things like publish beta versions or publish snapshot versions. And there was just lots of YAML and bash being copied and pasted everywhere, and then not quite sort of tuned into like a standard that we were using across the board. So, and this is a bad thing, right? Like, there is a range of different languages used in The Guardian. Scala is one of them, and we don't want the first experience of a developer trying to like deal with sharing their Scala code to be a negative one. We want them to be as smooth and easy as possible, and so that was a concern. So that's the difficulty of publishing to Maven Central, having to get these credentials, having to authorize them, all of this stuff, and also having a nice standard process that you could use that you wouldn't have to teach someone every time they came to a new project. But the project, it wasn't just, the problem wasn't just of difficulty, there was also danger, right? And the danger comes from binary incompatibility, which sounds quite innocent, but it's not. It's hideous and dangerous and comes for you in the night and crashes your server randomly at random times when you are not expecting it. So like you can do all the unit testing you can do integration tests, but you can't necessarily guard against binary incompatibility by testing. I had an experience of this where I wanted to upgrade a library to do with saying what stories are on the front page of our website. So there was a fronts API, we call it the FAPI client. Oh, is the microphone off? Sorry, what happened there? No, it's actually gone off, I think. I think it's died. Do you want to swap? Thanks, how's this? Yeah, thanks, that's great. So you just watch this for me and tell me if this goes out. Okay, thank you. So I wanted to upgrade this Fronts API client library. And you know, I had some like big changes I wanted to make. And I thought, before I do these big scary changes, I'm gonna do a really minor change, pushing out like these few point releases, and I'll just get that out of the way nice and clean so that I can concentrate on my big change and then release that later on, and we'll know if any problems happen that it's to do with my big change. So I make the change to the library, I release the new version. I still remember the version number. It's like blazoned on my soul. It was version 4.0.6. And I was like, yeah, this is just like a minor patch change. This is not dangerous. So this library is used in maybe 7 different live services at The Guardian. So I roll it out to a few of them. Everything goes fine. Everything's great. I roll it out to quite an important tool, which is literally the tool that editors use to put stories onto The Guardian's website. And it's all fine. And then maybe 7 or 8 hours later, the servers just start to die. This tool just starts to die completely, goes down, dead as a doornail, just randomly. And I'm like, how did I do that? What happened? And it turned out that it was binary incompatibility at the root of it. So if we have a look, dangerous, yeah. So if we have a look at the app server, so the app server is running all this code, and I had upgraded the FAPI client there, and that meant that I had a slightly new version of the Content API client, which depended on this library here, Content API Model Scala, and it depended on 17.5.2. But the app server itself also directly kind of depended on this JSON library, and that depended on 17.5.1. So like a pretty minor patch version difference, right? Now, what was happening was, in the tool that let people put things onto the website, there was a little search bar. And in the search bar, you could search for stories you want to put on there. So you might want to search for like cats. Give me stories about cats. Or give me stories about the environment, stuff like that. Now, most of the time, this search was working just fine, just peachy, completely great. But after about 8 hours, someone did a search that just happened in the results to include a podcast. A podcast came back in the results. Now, it just turned out that in the change to the content model between those 2 versions, an additional optional field had been added to podcast. And so this library here, the JSON library, is attempting to deserialize a podcast, and it's attempting to call a constructor. But it has been compiled with a constructor that has like 10 parameters. And the library now is being used with 11 constructors. That's what's actually in our runtime. And so it cannot work. It will fail. And it fails on this random occurrence of someone returning a search result that happens amongst that page to include a podcast. So there's that extra field. This is actually Thrift, but Scala classes was derived from this. And this is the error. This is a linkage error. No such method error. horrible runtime error, and it completely killed the server. I'm not entirely sure why the server died quite as heavily as it did, but it definitely did. So yeah, you can see that the JSON library is trying to call the Scala model, and there's basically, really horrible error, disgusting to look at, basically the wrong number of parameters. A pain. A random, awful pain. And so I thought about this for a while, and I was like, is there any way I could have guarded against this? Like, if I'd written a unit test testing the deserialization of podcasts, would I have been okay? And I was like, we have lots of different content types, not just podcasts. We have lots, like dozens. Would I have to write a test for each and every one of them? And what if the model change had been buried deeper down in the model? What if it had been some subfield of a subfield? Like, would I write a test for every single subfield? Some of these are really obscure. They're not used by editorial very often at The Guardian, so it's quite hard getting good sample data for them. I couldn't think of a good strategy for unit testing my way out of this. What I needed was a way to make sure that binary incompatibilities couldn't happen in our libraries. I needed to do that somehow. So that was the state of things in 2023. We had two problems. It was difficult and it was dangerous. And so what can we do? What can we do about that? Well, let's start with the dangerous part. So the danger is coming from the binary incompatibility, right? And it turns out that SBT has for a long time had eviction warnings that warn you when one version is getting evicted, but they're just warnings. So, like, here's an example warning, and you can see that it says warn, right? It says warn, because the thing is that, like, technically this might be useful information, but the truth is that SBT doesn't have enough information to know what's going on. It can't guarantee that this is actually a bad thing, and so it's just warning you, and you are ignoring it because you're busy. So why doesn't it know enough information? Well, the reason is, here's a version number, right? XYZ. And if I bump that middle Y there, what is that?
Minor.
Oh yeah, well, maybe, okay. Is it source compatible? Is it binary compatible? Okay, so yes, your instinct is very good, but the problem is that as far as SBT is concerned, as far as like the ecosystem is concerned, people at that point had not standardized on what version numbers meant. There were actually two popular standards in place, and there were several other ones as well. So these are the two popular standards within the Scala sphere. So Semver, which is very well known. Everyone knows about Semver, major, minor, patch, yeah. But also, a lot of Scala engineers were using this. I think the actual Scala library itself uses this. Epoch, major, minor. And so PVB, I can't remember why, but this is like from the Haskell community. They like this. And so if SBT sees a library and sees a version bump on that Y, it doesn't know if it's a minor update or a major update. And even then, there is perhaps some ambiguity about what qualifies as a minor update, what qualifies as a major. And so SBT introduced a series of things related to this. In particular, it introduced the version scheme setting. You've probably seen people complaining about this. So version scheme lets a library say what its version scheme is, what its numbers mean. Like, is it doing this one or is it doing this one? Okay, so it lets you say, actually, you know what? I'm using Semver. And furthermore, at the same time, they came up with a bunch of recommendations. Whoa, so much text, a recommended versioning scheme for Scala projects. So there's a fairly strong recommendation that you should use Semver, major, minor, patch, and then these are the rules for when you should increment those different numbers. So binary incompatibility, that's the worst. You've got to increment major. Source compatibility, that's minor. Patch, that just means you're doing a bug fix or whatever. So those are the rules. technically speaking then, we've got 3 things to do to get to a happier place where binary incompatibility is gone and the danger is destroyed, okay? 3 things. Use SBT 1.5. I guess everyone's doing this. Everyone's got SBT 1.5 by now, probably. So that's easy. We need to add a version scheme to our libraries. So just saying, we're using Semver. Easy. Then the hard bit, we've got to use version numbers that respect compatibility. And that is hard. That is hard because human beings can't do it. We cannot do it. I've been looking at this for a while, and I can barely quote to you the definition of what binary and source incompatibility means. And even more than that, what are they affected by? So technically speaking, I'm going to try and do this from memory. Binary compatibility means that you could take a binary at one version, replace it with a binary at another version, and the code will still run without misfix. So one compiled artifact can be replaced by another compiled artifact. They're binary compatible. If the code at a particular version can compile, then that's source incompatibility. That's source compatibility. Blah, 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 blah. Anyway, right, so, okay, great. So how do we achieve binary compatibility in Scala? When have we broken it? So there's a nice repository by Jacob called the Binary Compatibility Guide. And he gives a whole bunch of examples of things that can break binary compatibility. And the list gets, terrifying. So, okay, fair enough. First item on the call is mark methods as package private when breaking API changes. Okay, so that's a nice trick. You can do that if you want to make a breaking API change. Great. Second one, don't add parameters with default values to methods. Okay, so that's actually kind of what we fell foul of in the FAPI client, because we'd added a new optional parameter. The default value was none, but that wasn't enough to save us as far as binary compatibility was concerned. And then the third one is the one where I'm like, I've given up hope. Avoid case classes. But I really like case classes. I don't want to give up case classes, they're cool. And he has a whole bunch of perfectly valid technical reasons why, as you modify case classes, you will break binary compatibility. Okay, well, you know what, in that case, I think sometimes I'm going to be breaking binary compatibility. I have to live with that, and I want to know about it. I need to know when I'm doing that, and I'm not going to be able to work it out for myself. I don't want to spend time thinking about it. What this means is human beings should not pick version numbers. We're not good at it. We shouldn't do it, and we definitely don't understand compatibility. It's too hard. I'm not going to go around thinking how many fields I have in a case class. I don't want to. Which means that we need to get a computer to do it for us. And that's where this plugin comes in. This was released maybe a year or two ago, SBT Version Policy by the Scala Center. A great plugin. So this does a whole bunch of stuff. It uses MIMA and analysis of your dependency tree to work out your code as it currently is compared to the last published artifact you ever had, the latest artifact you published. What is the level of compatibility between them? Are they binary compatible, source compatible? And it can automate that process, which is great. The way you use it was not so great for us because what you would do in your library, you would set a parameter, the parameter called version compatibility intention, and you would say something like, I want this code to always be binary compatible, or I always want it to be source and binary compatible. And then version policy check would just crash your CI, would kill your CI if you ever did anything that wasn't binary compatible or broke compatibility beyond what you said you would tolerate. So the reason that wasn't suitable for the Guardian is that kind of we do just want to add in methods and functions, whatever the business needs. We want to be able to break binary compatibility. We don't want to be constrained, but we do want to know when we break binary compatibility, and we do want the version number to be correctly incremented to reflect that, so that SBT can do all of its sensible stuff about blocking bad incompatible versions being in the same JVM. This is actually really nice because SBT version policy didn't have that functionality, and we I wasn't confident that I could make the changes to this code base to put it in place, but we were able at The Guardian to hire one of the core contributors to this plugin, Julian Richard Foy, to make the changes for us. And so we worked together for about a week on getting those changes in place with this new mode of working for the SBT version policy plugin. And that was really nice to like sponsor some open source and get the functionality we wanted. So now it has this new superpower that it can, well, actually, just look at the length of this method name. It's a very long method name, but all of this functionality boils down to this single method here, right? So you add this to your SBT file, your build SBT file, and you say, when you release, call this method to work out what the new version number should be. I did talk to Julian about shortening the method name, but he didn't want to. So this is good. So what we've got is now a tool that can get us out of this whole danger, the binary incompatibility danger of having lots of library versions. That's nice. I guess the problem is that we've got a lot of repositories, we've got a lot of libraries, and we would have to roll this change out to all of them. We have to include the SBT version policy plugin. We've got to add this bit of config. We've got to educate the developers about what this thing means, about the fact that they're no longer choosing version numbers, that the version numbers are being chosen for them. And we've got to get them all to do a release. And then we've got to get everyone to upgrade to those releases so that they're now using the versions that declare themselves to use a particular SEMVer versioning scheme, and they have correct and sensible version numbers. So it's quite a lot of work, and the truth is that while this is really useful and makes everyone safer, it's not particularly exciting. It's like, you know, this is good, but like the prospect of doing like 40 pull requests across like all these different repositories just for this benefit doesn't. It's like, yeah, we should do it, but it doesn't really sell itself. So we want to pull in some more benefits to make this a more compelling change so that people are going to get onto this faster. So given that, let's look at the other bit, the difficulty, and also another danger. So the danger I'm referring to, I was thinking, you know what, the difficulty comes a lot from the fact that we haven't standardized on a good approach for releasing our libraries through CI. We need to make it like a push button operation, and right now it's a very manual operation happening on developers' laptops. So okay, we need to standardize on some kind of GitHub action situation that is going to release our CI for us, and everyone will like that much better. Also, we're going to need a single shared credential for the PGP key and for the Sonatype credential, so that developers don't need to get their own ones. So that's all good. But I was a bit concerned about how that credential was going to be exposed. If we look at the steps of a release, these are more or less what happens during a release. You compile and test the code, you set a version number, commit that change to Git, you create the actual jars from the class files, and then you sign them. You upload the artifact jars to Sonatype, and you push all the changes and tags to GitHub. So the thing is, a lot of these steps kind of require you to be using the libraries, all the libraries dependencies, right? You're pulling in all the plugins that Build SBT is using. You're also running the tests, and the tests are loading all the classes from like the dependencies. And so the fact is that it's not very hard to write a bit of code that when a class is loaded, it immediately grabs all of the environment variables and sends them to paste bin, just like to some malware place, right? It's not hard to write reasonably subtle malware that can just extract all your credentials and conceivably also do privileged actions. Because if you look at some of these actions, there's some fairly privileged things going on here. You have got access to a private PGP signing key. You're able to push stuff to GitHub, and you're able to upload stuff to Sonatype. And if you can upload to Sonatype, you can like publish a new version of one of our Guardian libraries that is full of malware. You can spread malware further. So we've got a lot of code that is including a lot of dependencies. Like, for any given library, lots of exciting and unusual dependencies that, you know, like for one project, one library, yeah, okay, so probably there's nothing hiding in that particular one library's dependencies. But if you think about that, we've got like 40 different libraries, all pulling in different exciting and exotic things. The odds start to get worse and worse. And I didn't like that. So let's just look at the breakdown of these stages here. So if we look at the two stages that are running the code that is controlled by the library, pulling in all the dependencies that the library needs to run its tests, there are these two. And I'm using the confetti ball emoji to denote those, because basically this is what is happening with the dependencies, right? We've got this lovely project, and out of it are falling all of these glorious dependencies, and there's glitter and excitement and functionality, all the things we want. But the truth is, we don't really know what's inside the glitter ball. We don't know what's going on. We're having a party, it's all a fun time, but we don't actually really know what's all in all of those hundreds of different dependencies that are pulled in to build our project. So we have two glitterball party stages, the compile and test stage, which is using build SBT and pulling in the dependencies, and then also create the artifact jars, which uses the publish action, which again is using the build SBT file. So we can look at that, and then we can also look at this. So with a lock, I've marked the ones that need privileges, and they are disjoint. They are not the same, right? There's the party code, and there's the privilege code, and they don't actually overlap. So we can achieve isolation here. We can do better than have everything running in a single JVM process. If everything runs in a single JVM process, there's not really any isolation. The code that does the compile and test can also access the credentials, can also push things to GitHub. There is no proper secure separation. But we can, given the way these things break down, we can separate them. Now, we can, in GitHub Actions, you can make a custom GitHub action. That can't really do more than one virtual container, but there's also a thing called reusable workflows. And every step in a GitHub workflow is what's called a job, and that is an isolated virtual runner. It's an isolated machine, its own container. It is completely isolated from all the other jobs, except for the values that you choose to pass on from one stage to the next. I can't remember what my next slide is. Oh, found that. Okay, yeah, so we can define a reusable workflow that can be used for all of our projects that breaks the publication task, the release task down into jobs. So let me show you what that looks like by doing a release now. Okay, so here's one of our libraries, eTag caching. That's a nice library, and we've got a pull request here that's been generated by Scala Steward. Okay, so I'm going to merge that. Okay, so now I want to do a release, and like, you know, sometimes I don't necessarily want to do a release straight away. Like if I was editing a README file or something, I don't really feel that warrants making a release. But now I've decided, yeah, let's make a release, and let's do it nice and easy. So we go to the release workflow, and we run the workflow. And it kicks off. And so now we can see the isolated jobs that are going to be the stages of the release. And so the first job is like a secure, trusted job. It's just doing some initialization. It's working out what kind of release we're trying to do. The next step is one of those party confetti ones. So here it's running the tests, it's compiling the code, it's running the tests. It's also got the job of running that SBT command to work out what the next version number should be. So it's doing the assessment of compatibility. So one of the outputs of this step, which will take a minute or so, is to work out what the version number should be. The next step is a secure one, where we push the release commit that's got that version number in it. We push it off to a temporary branch. So like, supposing this release aborts halfway through and fails, we haven't actually committed to the main branch. We try and delay that as late as possible. And then we create the artifacts. That's when we take the class files, we stick them into jars. And again, this is like party code because we're trusting the library's build SBT and all its dependencies. And that's passed on to the next step, which will sign them. If only there was good zoom on this thing. Oh yeah, it's like that. Right, so the next step is a privilege step. It will sign them. It will push a signed Git tag to GitHub. And that tag will include SHA-256 hashes of all the artifacts for reference. And then having done that, we can then kick off the upload of that to some type release, which again is just an own isolated container so the only container that has those privileges here. Equally, the only container that has PGP privileges is here. And we also, in this step here, update GitHub with like some nice new release notes. So it automatically generates the release notes that we want to see. So that's running along. Just to show you like some previous releases. So you've probably seen auto-generated notes like this before. This happens automatically as part of the process. I think these are fairly decent as far as release notes go. You can just see all the pull request numbers there. And I can click into the release for that here so I can see everything that went on. And there's a link back there to the release notes. So as you can see, you've got nice GitHub actions. We can run a release without choosing our own version number. The version number is chosen for us, and the correct version increment will happen. So this is way better than what we had in terms of like releasing off laptops. And it's, I guess, I would say, more secure as well, because we got all this isolation between the various stages of the job. That's not all though, because we also have support for preview releases. So it's quite often the case that when you're working on a PR and on a library, and you want to try out that library in some like code or staging service, you want to say, okay, here's my PR, here's a library. I want to deploy this to my staging service, and so you need to do a CI build of that service, which means you kind of need to have the artifact handy. So the workflow that we've created supports doing a preview release. So to do that, you just take the branch name of whatever PR it is, and you choose that branch name in here. And now I'm doing a, oops, is that clicking? Yeah, now I'm doing a preview release. Don't know how many of those I'm doing, a few. So now I'm doing a preview release, and this will do like all the steps of a release, but it will not update the master branch. It will just comment on the PR saying, here's your preview release that you can use and look at if you want to. So this has basically been a pretty big improvement for us, The Guardian. This is rolled out to like 90% of our libraries, and I've got lots of good feedback about it. People really like it. It is a reusable workflow. So if I just go to the repository for it, the workflow is in here. It's an open source repository, and there's a fairly extensive guide on how to use it. I've already use this workflow outside of The Guardian, so it's used on the Scala IO library, so we're releasing using that. And in principle, there's nothing really stopping you from maybe using this workflow yourself if you want to release libraries. The steps of configuration, there's the one-off organization setup where you need to get all those credentials, put them in GitHub secrets, and then there is a sequence of setting up your repository. And as part of the changes, to make them more attractive, we did quite a lot of sort of setting up reasonable defaults that meant that, for the most part, every single PR that introduced this release workflow reduced the size of the repository. It simplified the build SBT. It added a very minimal amount of YAML. So if you have a look at how you invoke this thing here, we're just invoking this reusable workflow. And we have to pass in a few credentials and then the permissions to write to the repository, and that's it. So the amount of boilerplate that has to go with each repository, given the fact there are 40 of them, is quite low, and that's good. So That is pretty much everything I wanted to tell you about this workflow. Have we got time for any questions? We must have time for some questions. Any questions? Yeah, hi. I told you it was dead. Oh, right, nice.
I went downstairs and it does not work.
Yeah, sure.
I have two questions, actually. First one. As you said, there's many changes. It's very frequent to break binary compatibility. I think that many times when you think you not, you do break compatibility.
Yes.
I'm quite surprised that in the library that you showed that releasing, you're only at on the major number of only 5. Doesn't it change the major one each time, maybe, or something like that?
Yeah. So the version numbering is based off what SBT version policy thinks. I would say SBT version policy errs on the side of caution, so it is more likely to do a major version number change than, like, sometimes I think maybe it doesn't need to. But on the other hand, numbers are free. Let's just get lots of big numbers. So I think there were some libraries up to like version 30 or something, and I don't mind. That's fine, as long as we're safe. Are we okay for time or?
Yes, we're
oh, okay. Yeah.
You're publishing on Maven Central. You're publishing on Maven.
Oh yes. Yeah.
I saw on your site that maybe you're also publishing on GitHub packages for your for branches, pre-releases. Does your workflow support publishing to GitHub packages?
That's a really good question. So no, it doesn't. It's only focused on Maven Central. I don't think we've actually done any publishing to GitHub packages. Have you?
Yeah.
Oh, cool. Do you find it good? These are for JVM artifacts?
Yes, they support Maven style packages, but the trick is you must pay GitHub to have access to the private ones, but fair enough.
Yeah.
But it does work, but you need to use some SBT special plugin to do that. It may be a little bit cumbersome, so if it could be done with this kind of workflow, it would be great.
Yeah, that's very interesting. I mean, while I was thinking about how can we make this experience better, I did look at GitHub packages. I couldn't see many examples of setting it up. Yeah, and it's quite nice to be publishing to Maven Central because every JVM thing in the whole world knows what Maven Central is, and I don't know what the support is across the board for GitHub packages. Maybe it's just an additional line of configuration, but it's nice to avoid that. It's good to know that you've had some positive experiences out there. Anything else? No? Okay. Well, thanks for letting me talk about it. Cheers.
Sorry for the microphone thing.
No worries.
Actually, change.
of you is using Scala outside the JVM? Okay. So Scala, of course, you are all using Scala within the JVM. Okay. I will present you how Scala JS is not a toy project. It's very useful project and very efficient. Also, you may know that now Scala also targeting the native platform with LLVM. And more recently, we can target WebAssembly. And for your information, the surprise that the WebAssembly support should, I thought it was coming from Scala native through LLVM. In fact, not. It's the Scala JS guy who built a linker from the intermediate representation of Scala JS to WebAssembly. But I will only talk of Scala JS. Shortly about me, Olivier, my GitHub handle and Twitter. I work for Ledger, which is a cryptocurrency company. We are doing a wallet, hardware wallet, quite known. Headquarters are in Paris, London, Montpellier, where I'm from. You can hear from my little accent, and Grenoble. Ledger, quickly, they are doing what is about security around the blockchain, from infrastructure to devices, embedded devices and services. Of course, we are hiring in almost all positions, from front, firmware, Scala, backend, PO, PM, everything. Why this talk? This talk because I love web app for a few years now, as my hairs can show. And I love Scala for 2 years, 12 years, sorry. Scala JS from early beginning, and FX System for 5 years. I'm not perfect guy because people are more smart than me in this room, but I'm quite happy with that. But yet, in another dimension, there is another constellation of tools: Angular, React, Vue, Ember, tooling. And really, I work for more than 20 years. I'm totally lost with the front-end topic. And that's quite frustrating, because when you are doing your pet project, you want to show something. And it's not frustrating. And then I follow the courses, the wonderful course of Rock the JVM about this topic, the IO rite of passage. That covering Scala backend, of course, Scala JS, the IO, Tapir. Who is using Tapir there? Okay, oh, nice. And Laminar. Laminar is a UI toolkit for the front-end side. Postgres, of course, nice database, the only database. ChatGPT and Stripe. So really, if you have some time to follow this course, it's just wonderful. So, go back to school. After 4 weeks, I 3 or 4 weeks, more than 50 hours of video. I perform. So outcome, Scala, okay, really rocks the JVM, definitely. But to set up this project, it's quite long, because you have Scala setup, Scala JS setup, NPM setup, Vite setup to work in a comfortable situation. It's quite long. I forgot to start the timer, sorry. Up, I put my timer. Not to be up. I'm handicapé. As you can see, I'm not using timer. The time is not on my side. Anytime. Up, stopwatch, sorry. So the setup, you will see, is quite big because there are many tools to set up. So it's very error prone. I don't remember the time for the first setup. It's about 20 or 1 hour of tweaking configuration files. And also starting the development environment is quite long, because you have some Docker stuff, some backend stuff, some front-end stuff, Vite to set up. So the agenda will be how to set up this in quite a fast manner. Classical application, front and the back, and Postgres. And sorry, setup. I said, yep. So classical application, a front and a back. And how to deploy this as a standalone jar, Docker, or even if you have time within Kubernetes. Kubernetes using Argo CD and nice stuff like this. The setup. What is the setup? It's build tools. Build tools, we have NPM. I think everybody who is doing a little bit of web knows. As node for package manager. The Vite. Vite is a tool that allows you to out-reload your application without doing anything. SVT. And just for this, I have two processes. Okay, we have SVT to build the Scala JS, Vite to synchronize the browser, and the browser to test. Besides this, we still have the backend. Backend, we have also an SVT to build the backend and Docker file. So even for Kubernetes, I don't think I will have time. There is a tight communication between Scala JS and Vite, of course, because Scala JS will incrementally build your application, and Vite will update your browser as fast as possible. So it's a very bunch file of configuration to set up. So first time is very funny. You do this. Why you struggle, but it's okay. Second time it's not very funny. So after following the courses of RocksJVM, I have an idea of a new pet project with Scala JS. And I say, oh no, I have all these setups to do. Let's do a template to do this. Everybody knows G8, the templating of Scala that is embedded in Scala. This is the way up. Here I have nothing in this folder. Okay, I just use this scaffolding tool. If the network is there, so it will go through GitHub to check up the templating, run the templating, and we are done. At this point, I have set up a project to be able to fully develop this application. But we still have to start Docker. Let me check that Docker is running. It's running, and this container, it will conflict every time I have this error. Okay. So we have to start Docker to Docker image for Postgres, start the backend SBT, the Scala JS SBT, and the Vite process to use this. And what I just have to do now is just this. I just have to enter in this folder, and it should run VS Code. I don't know if you know what we can do with VS Code, but there is a very funny feature. With this small file task in VS Code. Who knows this file? Oh, nice. Well, this file can allow you to automate something when the folder is open. Okay. On open folder, I will run in sequence few tasks. First task to set up, to catch all the dependencies, and to run the demo. So if I go to the VS Code, now it says, oh, you should first import your Scala to determine. I just need to know the version of Scala you have. So it runs blub install. In general, it works. So we just wait to the metadata to be built. And as you will see, you will show me. It's quite long, sorry. Check. Up. Okay, good job. So now it runs the setup. The setup is essentially making an npm install and building the whole application the first time. So you run an npm install, everything like this. In the meantime, I continue to explain you. So if we run the setup, checking npm install and SBT, and run the setup, and after it closes and run the demo for application. And as you can see, it will run in parallel these 4 tasks. Starting Docker, the SBT for Scala for the backend, SBT for Scala JS, and npm Vite. And if I go back there, you can see my 4 processes. And if I click, sorry, I just wait that everything is compiling, because first time it's checking all the dependencies and everything as always. And now I just have to open my browser And that's it. I have my web application that it's just a sample that allows to register you and have access to secured pages. The design is by me. I thought it was nice, but everybody is joking, so it's maybe not so nice. So, as you can see, I have a setup page, okay, to register the user. I will show you quickly how it works, but the basic are really simple. I have some debug information, everything. I can create my user. The user is now in the database, and I can log into this UI. Up. Not secured. And now, because I'm logged, I have access to my settings. Okay. And if I unlog, everything is active. If I reload, it go back. Okay. So everything is fully reactive, and you will see there is more or less zero code to do this as an end user. How it works? Okay. So this is the task, the setup. One line to scaffold the project, one line to start the development environment. Quite cool. This is all the SBT plugin I'm using. I will detail some of them. For Scala JS application, this is more important, that allow you to mix in the same SBT project Scala JS and backend stuff. This is pure Scala JS. This is for the bundling your application, because you will be able to bundle the application as WebJar. I don't know if you know what a WebJar, but it's more or less an archive in the Java world to expose web resources. Scala BType, it's a plugin to allow you to convert TypeScript definition to Scala. So it means that with this very nice tool, I can use almost every ecosystem existing in TypeScript in Scala. And in the runtime, it will be still Java JS that will be run. Twirl is a static file tool, quite useful sometimes. And Spray Revolver, it's a plugin that allows you to reload, not auto-reload, but reload your web server without any operation. So what is the structure of this project? A server and a client. There is a nice strange beast, which is cross-project. That is not really an SBT project. It's something that can be derived in server part and client part. Meaning everything you put in the cross-project will exist on both sides of the wire. There are some settings. Not very complicated, but it's pure SBT. Okay, you choose a JS platform, JVM platform, also native platform if you want all the target. And as you can see, with doing just this, you say, oh, this is the JVM part, this is the JS part. In the SBT file, you have to in the server process, you depend only on the JVM part, and on the client part, you depend only on the JS part. Quite obvious. Setup is done for the backend. For the front end, I don't know. I will quickly run this because it's quite long. There is some pure development dependencies. Here it's Vite. Vite is the tool that is all reload your application. And dependency, runtime dependencies. I use there a web UI component and Chart.js as a sample of library that I will use from TypeScript definition. This is the tooling for the Vite setup. I talked yesterday with somebody who tried to play with Scala JS. This setup is not that funny to do because there's many small errors you can do. As always, there is a plugin for Scala JS for Vite. You just say where is your build SBT, what is the ID of the project in your SBT, and that's it. So the front end, the application will be a front end part and back end part. The front end I will use Laminar quickly, IO as a effect system, and Tapir has API definition and client, server, everything. On the backend, Tapir, again, the IO and Quill. Quill is one database layer. I won't go too much in detail. The share module will have the IO for the payload manipulation, because we have many payloads to transfer between the server and client. And Tapir also to allow to share the definition between the server and the client. So that's very, very cool. And this usage, it's simple, but I didn't thought it was so easy to implement. And that was the point in the Rock the JVM tuto. That was very amazing. As you can see, Zio is everywhere, in my heart also. And Tapir is also everywhere. Okay, so we have a API definition, API usage everywhere, and Tapir everywhere. What can we share? What can we share between server and client? Me, before following this course, I was only sharing payloads. Okay, just not to avoid to have a discrepancy between server and client side. But we also can share the business logic, validation of some stuff, error handling, and most importantly, the API definition. And this is I think the very most interesting stuff of the Rock JVM courses. What can we do with this? So Tapir, quickly. Tapir is something that stands between HTTP transport and your FX system. CAT, ZIO, whatever, future, or even async, not async, direct style. And I will only focus on ZIO. Who knows ZIO? Is there? Okay. Who knows CAT's effects? Well, so I won't go too far in ZIO and declaring my love to ZIO then. But you know, ZIO, very quickly said, it's just a promise of some computation that can need some resources, some dependencies on the environment to compute. That may fail with an error, no more HRT for the CAT's lover. And then can produce, of course, a result. So this is sometimes this is a very we can show ZIO like this from R to either an error or a result. That's quite fat. That's why there is some aliases that can shorten the syntax. Mainly task. Okay, task is just like an IO for CAT's user. So Tapir. Tapir, about half of the people that already use Tapir, I think. Tapir is something to handle HTTP API from server and client. And the first point is to define your API, of course. So there is a very, very rich DSL to define your API. Like this, I will show you how the endpoint to create a user in the application is done. As you can see, it's just an endpoint that consumes a person, may fail with a throwable, and output a user. Okay, user is a registered user. You should give a name to this endpoint because it's the ID, a verb, HTTP verb, a path in your URL, what it consumes, what it produces. Okay, it is done, so of course I need encoders, everything as implicit as always. You can see that the throwable is not in there because in general the error handling is common to all your application, so you gather this in an abstract definition. Where there in this kind also prepend every endpoint with API but in details. So from this will allow me to develop to implement the server side of the API. But also the client side, and globally just a post to put something like this, password, user, name, everything. From the server side, then, let's imagine I have a service to register my user, like this. I want to implement this controller. This controller will be a class or case class, I don't care. and that will be injected with services, as in a classical application. And Tapir provide this extension point as a Scala 3 syntax that I just call on this endpoint. And this is the place where I put my logic. As you can see, the mapping is straightforward. It's just forwarding the payload I received to the service layer. Because this is Scala 3, we can shorten the syntax. Maybe too much sometimes, I don't know. But this is very compact. And I give a name to this value, and I have implementing my endpoint, my server endpoint. This is as simple as that. What I didn't show you, for people that don't know Tapir, is that this produces for free your Swagger exposition of the service. Swagger or Redoc, if you prefer Redoc. I prefer Swagger. I think this is more easy to use, personally. So you can pay with your API. Everything, the schema is very finely defined. Oh, sorry. The schema is, thank you. The schema is really finely defined by either annotation for documentation or types. Focus, c'est pas ça. So as you can see, it's very easy to implement the server side of the call. If I generalize this to all the endpoint for this service, it's always the same logic. You have your endpoint, you apply the logic, and you put the content more or less complicated. As you can see, there is two public methods there, and one that is not public. Because you can see it because it will receive the user ID when connected, queried with the rest of the request. And this is also handled quite all automatically to decode the bearer token and everything. We gather all our endpoint in a route to ease the process, and that's it. Now I need to build this controller at some time. So I need to inject the person service and GWT service. With the I/O, there is this parameter layer that is the constraint on the environment the I/O is running. Meaning that this I/O to be executed must have access to person service and GWT service. So when I do this little syntax, I just declare an I/O that will produce my controller, given the fact that I can have access to person service and GWT service. But in the same way, the person service also depends on many other dependencies. Okay, repository, everything, GWT service also. So at the end, you have a bunch of files you have to assemble together. When you do this with cats effects, you do this by hand, as far as I know. As far as I know, because I'm doing cats on my daily job, so I know what I'm talking about. So it's funny, but it has some limits. Using the I/O, there is another data type that is called layer. That is just an abstraction around the constructor, in fact. Okay, it's something that will help you to produce some object. And this time, it's the same logic. There is some dependencies. There is some. This layer, for example, will produce a person service, given the fact there is other layers that can produce all this different stuff. And nice stuff, or nice element of ZIO. ZIO love making small macro to ease the developer. Okay, for example, this macro is just using the constructor parameter of this case class to derive the layer. You don't ever have to write the layer. Sometimes you have to write them by hand. Sometimes you can rely on this. So at the end of my server, I have a bunch of services, bunch of controllers that must be wired together. So this is, for example, the end I/O that did all of this, and all you have to do is just to put all the layer in a raw flat way, And there is this macro, magic, the IO magic at the first time, that will figure out how to wire everything. From top down, beside, it's just some people are mad on the world. And to give you an idea, for this simple project, also, at compile time, the IO produces this. Okay, it produces the link to go to Mermaid to understand how your services are wired together. At compile time, I don't think I will have time. It's in warning, in compilation warning, you have a tree with a nice ASCII art, or this link to Mermaid. Quite funny. Hop là, pardon. Hop là. Okay, so now I have some endpoint on my controllers. Now I have a browser, and I need to call this endpoint to use the API. So we need to provide a HTTP client for the same endpoint. And this is even more fun, for me at least. And saying Tapir also have a server-side client side. We will stay in Scala world, fully type safe, of course, and we see everything will be reactive. The call to the API and also the processing in the UI side. And with, I think, really a minimal of boilerplate, because I really don't like boilerplate code. So same part. I have this person, the formula is filling, and I want to call my API. As you remember, the API was like this. It was consuming a person to provide to produce a user. So what I just want is just I want to use this as a function. In fact, but that's the case. In fact, I will, after few extensions, be able to do this. I have a main endpoint. I give you this case class and go make your life. The magic is that something that will produce an IO, okay, an IO, the IO that will depend on the HTTP client, of course, because to send the request, I need a client, and that will produce a user. And there is another extension, emit2, that will run this IO and pipe its result in bus to handle the result or the error. So I spoiled the question, but there is two extensions in action there, in fact. This one and another one. Who guess where it is? Where is the first extension? That is Scala 3 extension. Okay. Sorry for people doing Scala 2 or implicit class. In fact, there, and I find this very elegant. It's not for me, it's from Daniel from RocksJVM again. Because remember that create is just a Tapir endpoint. It has nothing no relation with the IO, with cats or nothing. It's nothing. So what's happened is that I've extracted this logic from the RocksJVM in a library. Okay, so we just have to have this import, and that's it. Everything will work like this. So it's magic, not. So I will short you explain how it works. It's not that complicated, in fact. It's very illustrated how Scala 3 is very elegant in many topics. Like Tapir had the server logic extension to provide the server logic to the endpoint. We build an extension that is targeting an endpoint, okay? An endpoint that throwable exceptions. This just provides the apply method. Okay, if you know Scala, you know that as soon as an object has an apply method, it's a function. Okay, so now my endpoint can receive the input. The input of the endpoint can be given to this to produce an IO from the IO. There is no magic. this is how we retrieve an element from the environment of the I/O, and we just fed map to the client, to the server, no, to the client, the endpoint definition and the payload. To go to the full detail, this endpoint definition is then received by this function and will produce this ZIO that can be reduced to a task, as I explained last time, and just forward to the backend, to the HTTP backend, the request. And we are done, in fact. This is how, in the end, the HTTP backend is implemented with, is interpreting the endpoint to produce the client, HTTP client, okay? It's wiring, but not that complicated. So at this point, I have my endpoint definition. When I give him the input is waiting for, I have an I/O that is ready to be run. So I need another extension. This time, extension Scala 3 still, that is targeting this time this I/O that depend on the client. And what it's doing is simple, in fact. It just say, okay, run the I/O, tap the error, tap, okay, it's oh, already. Tap is to use the result, but don't touch it. Okay, it's still there. So I tap the error to push in the bus error bus, and I tap the result to push in the result bus. In the end, I have to run the I/O with this, and providing the client, the HTTP client that will, in development side, will be using the Vite URL, and on the deployment side, will be using the production URL. So under the hood, I have more stuff like this to be able to use a different origin client, because to handle the cores, and also to support the bearer token, meaning that on the client side, when I use, if we have time, calling a secured endpoint is nothing more than calling a normal endpoint. Okay, all the mechanic is automatic. If we look in the local storage, if there is a GWT token. If yes, you take it, you forward it to the client. You, as a user, you don't know that this service is secured. This is how it's implemented. The only difference is that this endpoint now has a string there. This first element for Tapir is a secure input. Okay, meaning I have a token. I have this token to handle. And my library takes the token and converts this to your user token of your application. This is extended as a library. So as you say, it's just endpoint enhancement, marshalling of JSON. Of course, I don't use everything is done automatically. Error handling and fully reactive and type safe. And I think one line one import and one line to use. I think the boilerplate is avoided as much as possible. Bon, Tapir. Okay, I'm just repeating myself. Laminar, very quickly then. So who knows Laminar there? Nobody? Oh, really try Laminar. Laminar, it's a toolkit that provides basically some reactive component. A var is something that you can read and set and get automatically, and being notified when things changes. Signals is just a reading only variable. Event stream for events, and event bus to write to event stream. Doing this, there's two functions. One function to read and one function to write, the opposite. Well, you can see quickly the demo, but basically it is as simple as that. Non, ça c'est moi. Bon, on peut y arriver. Sorry. This is the running code. You can see it's reactively update the DOM, and it's very efficient. Okay, it's very minimalist. The guy who's implementing this, I don't know, he's a creator of the DOM model. He knows everything. Every event of every domain it's a mutant. Really. Up. So I show you quickly how I could set up on the application. And this is the whole sign up page. Okay. This is all the content. I think you should say, oh, but where is the formula? Where is everything? In fact, the real code, okay, with some other CSS stuff I put. Okay, it's probably not optimal at all. But this is where, as you can see, I have a var holding my person, my domain model, my domain object. A bus to receive the result of the API call, the error and the good result with the pop-up. I don't show the code of the pop-up, but it's okay. And this is in one line to use my case class and derive a formula, okay, from with a manualia, and one line to call the service. I think it's not too complicated. The formula derivation, quick demo also. As you can see, there is the design is also by me. And there is simple cases where I have a case class like this, okay? And to render, just render the formula, okay? And you have the double binding there. And everything is supported from opaque types, okay, where the data is obfuscated, from either type, if you want prefer cats or dogs. So as you can see, my case class there as a header, and the header is rendered as a two side panel. But also validation with a famous library from Raphael. If you don't know Iron, check Iron. It's just amazing. It's a library, as you can see, that can allow you to define, I don't know, opaque types, something like this. Type constraint. Type constraint at the type level. For example, this value must be greater than 8. Okay, and the formula derivation under this quite smoothly. Okay, I didn't. I use code to handle this, of course, but at the end user usage, nothing to do. Okay, your formula is read because your data is not valid. Also handling the options, right? Because it's option, I can remove the option. Stuff like this, seed classes also. Okay, you can choose everything, list, everything. So you define your model and go in the UI. So quickly, because I only 2 minutes, I guess. Up. So voilà, it's a small library, also inspired from Kit Landon, which is a great speaker in the Scala ecosystem. And you can see very easy to use and funny. And this for prototyping is very cool. Scala type, I tell you, it's from TS. It builds the wrapper, the Scala wrapper classes, and put this in your IV directory. So it is done only once because it's very long to process. And then you can use from the jar to Scala JS and to JS, and it works very nicely. If you know char.js, for example, char.js, because I'm connected, no, there. I can access to char.js, okay? It's just a JS library, but I'm just using this in a Scala way, so thank you. I'm just using the JS library in Scala way, so every type and compatible with laminar in fully reactive way. So you can do really amazing things. I don't have time, but if you want to go to production, it's also one-liner. This is to build only one monolithic server with the backend and frontend. You can build push with Docker or also push in Kubernetes. Okay, I made all the Helm files, all the for Argo CD. I don't know if you know Argo CD, and the end using this parameters because you need some GitHub stuff to push your GitHub files. When you want to go to production, you just have to tag your repository, push the tag, the CI build the images, go in the Docker registry, Argo CD listen to the Docker registry, check the images, update the M file, commit the M files to the GitHub's policy, and Argo CD update the application. So no more boring stuff to do. So out of the box, scaffolding, form derivation, scalability type integration, HTTP client very easy to use, Docker deployment, Kubernetes deployment with Argo CD. This is really nice stuff to play with. I encourage you. What I didn't cover in the template is all the testing possibility we have with the IO and things like this. Observability topic, GraphQL, because API REST is a good thing, but GraphQL is also a very nice tool, and there is Caliban, which is a very nice implementation of GraphQL for Scala. WebSocket, web security, WASM. I want to play with WASM, absolutely. I don't have time yet, but I want to. And microservices also, with some other things than REST, like gRPC. A very nice implementation of the gRPC that is also compatible with Scala JS. So it can be very cool. Resiliency topic. It's a thought topic. I want to play with Istio also and integrate Istio secret breaking, things like this. And that's it, and GitHub Action. Some resources. I encourage you to really follow the courses of Daniel. It's very amazing and cool. That's it for me. Thank you. Oh, si vous avez des questions, bien sûr, avec plaisir.
Hi, thank you very much for the presentation. I have 3 questions. The first one is, you said that Lamina is a type-safe API that can define a combinator to make it active UI. Does it produce type-safe HTML answering that every node is validated by the
no idea. Okay, no idea. What I know is it does not know SSR, server-side rendering.
Okay.
It's only browser.
And the second question is about form generation. It looks very interesting, but sometimes when we try to deal with form generation, we have to have some very specific corner case, and we know that the validation may take more information than just the regular data type. And is there a way to hook, for example, just one field of the form? So going for a free selective applicative?
Yeah, that's the question I have to handle with Raphael.
Okay.
Because very good question, because in this time I have to have a valid class to be able to render it. So it's not ideal.
Nice. And the last question is maybe a little bit conceptual, but I think that REST API are pretty good when you want to expose a public API and to deal with different technology for client-side and backend-side programming. But since we have one technology that can deal with, for example, like you did automatic serialization between client and server, why relying on REST when we can, for example, go for something what we call tierless programming that will handle the RPC process between some fragment of the page and using shared continuation and shared state to have a more precise way that we deal with the application, stopping to separate everything for random reason.
Clearly, there are plenty of ways to do this. Also, it depends on who we are working with on the other side, as always.
Let's imagine that we are dealing with the full stack Scala, is there a possibility, for example, to define a component on the client side and to use it on the server side and vice versa, and to deal with what we call speeded compilation, going to get a compilation scheme that allows to have multi-server program.
Very good question, but I don't understand what you are talking about, to be honest. But let's talk after, clearly. But Scala JS is fully compatible with Scala. So you can do everything you want.
So how to manage stuff from the backend and the frontend, and to have a proper compilation scheme where everything is accessible by availability. So stuff that are just for the client are just for the client, but you can have shared information that have a different representation that can be data from the backend and the frontend.
That's the case. You can mix many things many things are shared between client and server.
Maybe we'll talk about that just after.
Yeah, probably. Yeah. That's the point. The API is shared. All the contract API and payload are shared between the both. Take after. Thank you. Pardon.
Have you tried or will you try to make this kind of project with Tyrian instead of Lambda? Are you experimenting with it?
No, I didn't try Tyrian. To be honest, Tyrian is using cats in the background.
You can use Scala IO.
As enough cats at work. So I do this on my spare time, okay, clearly. And of course, everything is open source, of course.
Okay,
thank you.
Thank you very much.
I said Tyrian. Thank you.
Ça veut dire que c'est dur à trouver.
Non, moi je suis arrivé avant. Ouais, la 7.
Ouais, c'est David.
fate of the ship.
Okay, can we start? Okay, let's take more seconds for the last people to sit down and we could start. Okay, I think everyone is already in the room, so I think we can start. So, hello everyone. My name is Mateusz Kubuszok. I will be showing you my presentation about semi-automatic and automatic derivation from the user's perspective. So don't worry, I will not show you any sort of macros, shapeless, magnolia, mirrors, things like that. I will only tell about how authors picking up which tools they use to designing the library affects you as the users. And also mentioning a little bit how other libraries, like some libraries do this and how it affects you. So probably most of you are used to using some libraries which are based on type classes. Maybe you're not aware of that, maybe you are, but basically it's really hard to have a Scala code base which isn't based on some sort of type class derivation and type classes and all of that stuff. Perhaps some of you who are used to those kind of libraries notice that sometimes you are able to use something called automatic derivations. Sometimes you have to manually tinker with things with this thing called semi-automatic derivation. Sometimes you suffer due to long compilation times or really bad compilation method errors, which tells you nothing. So in this presentation, we will try to talk a little bit how all those different choices, not made by you, but by the basically libraries developers, affect you as a user, and if there is something if we could, do better and expect more of all those libraries. So a little bit about me. I've been working with Scala for over 9 years. I gathered some experience, jumped between many different projects. I saw about as much of all those weird stuff as many of you in this room have seen. In the meantime, I was also doing a little bit of open source. I think the biggest stuff I co-authored was the Chimney library, which I am co-maintaining for over 7 years now. Maybe some of you heard about this library. It's one of the reasons, it's the stuff that is written here as the stuff I am developing. However, I will not show you any sort of Chimney stuff on this presentation. I was also blogging a little bit, and at some point I also wrote this niche book when I tried to explain how Scala is working on JVM, how we can debug that, how we can understand what is Scala actually doing on the JVM, how it impacts us. Sometimes it gets useful. But enough about me, let's talk about today's topic. So the plan for this presentation is as follows. At first we will start by reminding what is a type class, because even if most of you and most of the people out there were using type classes in this way or the other, maybe not everyone is aware what it is and how they were using it, and maybe someone is just learning Scala and seeing all of the stuff and not necessarily understand what this stuff is about. Then we will also speak a little bit about what is this type class derivation, because basically it's the topic of this presentation. And if someone came in this room, straight from the university, never working with Scala, they might be thinking that perhaps derivation have something to do with integrals and calculus, and no, it doesn't. It's just the same name, so it would be good to mention what it is about. Then we will talk a little bit about these things called automatic and semi-automatic derivation, because for some reason in Scala we decided to use two of those two flavors of the derivation are needed. So perhaps it's worth knowing why they are needed, or are they actually needed. Then we could take a look at, and this first example will be based on Circe, and I am calling it this derivation a la Circe because this library really propagated this pattern of automatic and semi-automatic derivation, whatever it is. We'll talk about it later. However, not all the libraries out there are following it, and as an example of that, we will take a look at JSON-iter and how it affects you as a user when you use it. And finally, I want to tell a little bit about something I call sanely automatic derivation, and I'm calling it sanely because after years of working with derivation and all those libraries, I started to thinking that this automatic versus semi-automatic derivation is kind of insane, especially if you want to be user-friendly and beginner-friendly and explain to people how they can use stuff in as simple manner as in Java, as opposed to doing all this weird stuff that you sometimes have to do when you're working with the way we got used to doing. And obviously, as I said before, I want to talk from the user's perspective. So I won't be doing any sort of Magnolia tutorial, Shapeless tutorial, Mirrors tutorial, and I will not show you any of such code. Even though this code, whether or not it's used and how it's used, will be affecting some of the results that we'll be showing here today. But if some of you are being curious about how I got the results that I'm willing to present to you and rerun the benchmarks and then see where I got wrong and how I don't understand how to use Shapeless properly and how I don't understand how to benchmark JVM properly, you can always take a look at this repository when I'm storing all of the code that was used to generate the results that I will be showing you today. I will show this QR code also at the end of the presentation, so don't worry if you will not be able to catch it right now. I will be showing it also later. So let's start. What is a type class? As far as I care, it's first of all an interface. But it's not any interface, it's an interface which has some type parameters. That is really important. If you have interface with no type parameters, you cannot really call it a type class because implementation of this interface will be provided by the compiler to you based on the type solely. So if you have an interface with no type parameters, well, compiler can only know that there is one implementation it can provide to you through this magical mechanism called implicits. So if you want to have a variety of interfaces with a variety of implementations, they have to be distinguishable by some of these type parameters, actually only by those type parameters. So maybe some example to understand what do we mean by that. Let's say we want to have an encoder. Example from the CRC library, obviously. So we have some type. Maybe it's a case class, maybe it's a sealed trait, maybe it's an enum, maybe it's some primitive, whatever. And we want to turn it into JSON. And we have, let's assume that we have this JSON, which is JSON represent as some data which we could render as actual string or whatever. And this is the interface. And then we are using this implicit or givens, as they are called in Scala 3, as this mechanism of providing those implementations. So we could provide an implementation for string, for int, for double, for example. Then we can use, let's say, extension method because we want to be very convenient to get that implementation by its type and use it. First, as this way. We have a string. We call this extension method xString. As a string, Scala will figure out, OK, I need to have the implementation of the encoder, which is implemented for strings. So let's see if we have some given for it. It's fine. OK, let's use it. Same for ints, doubles. It's simpler than it sounds. You just have to get used to it, experimenting with the code, and it will click, believe me. What not always will click is, what if there is no implementation for your type? Nobody wrote it, nobody provided it. You have your type, you define it, and nobody wrote special implementation just for it. And you try to use this extension method. For instance, we're defining user, address. We have some value. We call as JSON. What the compiler would do in this case? Well, out of the box, you will get a compilation error telling you that, sorry, my friend, there is no implementation for this type. Which kind of limits this usefulness, because then you would have to write all of these things yourself and provide them one way or the other, and it's kind of annoying, so why not just define those things explicitly and call them explicitly and so on. But that's why Scala came up with this thing called type class derivation. And because this presentation is too boring, I will add some colorful slides that nobody would understand, but don't worry. The point of this slide is not as much about explaining all of this stuff, how it works. Basically, all I want for you to understand about typeless derivation is that we are getting some type, decomposing it. Most of the time, it's about checking if it's either sealed rate or case class, and then trying to find if do we have some implementation for every single field of a case class, or do we have an implementation for every single subtype of a sealed rate? And then have some way of combining them together to get the implementation for your type. And if you are you are wondering, okay, about how the compiler know how to combine those smaller implementations into this bigger implementation, the answer is it has no idea. It has no idea. You are, as a library author, telling it how to combine the smaller things into those bigger things, and then that's where all those libraries like Shapeless, Magnolia, etc. come into place. So if someone did this, and we'll look at it, and we look at how like Circe does it from user's perspective, no implementator. Reminder: we have this trait, which has to be implemented for us to not by us, maybe by compiler, to turn some arbitrary type into the JSON. We have this extension method to make it slightly more easier to use. We have some types that we want to actually encode as JSON. And we want to have results basically like this. We have some value. If we run as JSON on it, we want to get something like this. If we have user and we run as JSON on it, we want to have something like this. Basically, we want to take every field name and turn it into an object key, and we want to take all value and encode it with the encoder for this value. So one way of achieving this is called automatic derivation. Basically, it boils down to the fact that we have some magical import, and as soon as this magical import is in scope, some way, magically, those implementations becomes available. Compiler is able to provide them for us. On the other hand, semi-automatic derivation, it works in a slightly different way. It works like, okay, if you want to have an encoder for address, we can build it for you, but you yourself have to put it into implicit scope. Then if you want to build an encoder for user, we can build it for you, but you have to put it in implicit scope. And so through semi-automatic derivation, you can use this method to put everything you need into this implicit scope from which things could be fetched, so that you could just use it with those extension methods. A little bit more works, but for some reason, we'll see why people are doing this. So how does things like this impact you? Well, let's discuss automatic derivation. We wanted to understand how this works and how this summoning of encoder address actually creates this instance. Basically, what compiler does is do something like, let's see if there is an existing encoder. Once it sees that, no, sorry, nobody defined that before. So as a fault, because if it did, we could use it. But if nobody did, then as some sort of fallback mechanism, let's see if an case class is if an address is a case class. If it is, then we can see, okay, do we have implicit for the first field of this case class? Yes, good, let's keep on going. Then let's take a look if we have an encoder for another field, and so on. If it will be able to find encoders for every single field of this case class, it will combine them together and return this nice little, or not little, encoder for the whole thing. If it failed at any step, then compiler, well, it will fail. Semi-automatic derivation of address would be very, very similar with one difference. There would be no this step where we are checking, does it exist? If not, let's, as a fallback, generate the stuff. Which guarantees that every single time you are calling this semi-automatic method, it will return you a new value. And this is kind of important because usually when you have those derived encoders, you are doing something like implicit val, my new value, equals derived encoder. And if it would be able to fetch this value from the implicit scope, not as a fallback, but if it would always try to find this value and only as a fallback create a new value, you would have this issue that, well, all those implicit values would be calling themselves. So you would have circular dependency or on initialization, depending on if it's val or lazy var or def, you would have either stack overflow or null pointing exception, so not necessarily what you want. Which is why basically, if you want to use semi-automatic derivation, it always has to return a new value because that's the only way to prevent you to get this circular initialization, errors on initialization due to circular dependencies. If we try to do this automatic and semi-automatic derivation on user, and reminder, user is having an address, things are getting a little bit more interesting because when we want to receive this encoder for user, then at first, of course, it will check, did someone define that? Nope. Then it has to check, is it a case class? Yes, okay. Is there an implicit for string because the first field of that case class was a string? Yes, okay, let's use it. Then is there an encoder for address? And here where things are getting interesting because this stuff right here is basically repetition of this stuff right here. So automatic derivation out of the box is recursive. You're not only deriving the implementation for the top level thing, but for every nested stuff inside for which nobody provided the implementation, it will derive things in depth. Meanwhile, if you try to use semi-automatic derivation of user, the moment it gets to this address encoder, it only checks, did someone define it? If not, sorry, I'm failing. Which means that basically if you are using semi-automatic derivation and you are not importing automatic derivation to use them both at once, you have to define every single intermediate type if you have this deep nested hierarchy of case classes. And if you are wondering why I'm showing you this instead of code, then first example, we are focusing on the user side of the story, and we will see some user side examples later on. The code is in the repository, and there's a lot of this code. And also, if we wanted to dive deep into how all these Magnolia, Shapeless, and stuff work, all of that stuff works, we could probably spend next several hours here, diving deeper and deeper in all of that stuff. And the outcome would be that everyone will be completely PTSD'd with all of that stuff, and we wouldn't even go to the part where, okay, but how does it affect me as a user? So forgive me for skipping all of the implementation stuff. I will only move on to how you as a user perceives those choices by the library developers. So why people bother with semi-automatic derivation? Because so far we only saw that there are those two flavors, but we haven't seen why people are using it. So the first reason is that people want to make sure that they have the same implementation everywhere. If you want to make sure that every single place in your application needs the same behavior, the same stuff, well, the easiest way to achieve it is by defining this thing only in one place and then calling that single place. It's basically the only way to guarantee by construction that you're using one implementation everywhere. And this is a use case that I'm not going to challenge because it's valid. The other reason why people are using semi-automatic derivation is speed. And by that I mean that there is a tremendous amount of anecdotal proof in the community if you speak to people that there were cases when they were using automatic derivation with CRC and then they have this one little nested hierarchy of JSON they had to encode and shove somewhere, and then they found out that this single file was compiling for 5 minutes, 10 minutes or more, that they have to manually tingle with those files and never understood what is actually happening under the hood, but suddenly the compilation went from 2 minutes to 10 minutes or even more. That their code was slowing down, that it was excruciatingly slow on the production. And then found out that it was all due to automatic derivation, and when they replaced this automatic derivation with semi-automatic derivation, suddenly it's all solved. No issue, easier to maintain coherence in your code, compilation times went down a lot, performance as well. But that was long, long ago, and people are still writing guidelines where they are telling you that you should always use semi-automatic derivation. Never use auto, it's banned in our code base, it's banned in our company. You should use semi-auto in some trait and then mix in your trait, and never do this little import because this little import broke our CI, things like that. A lot of anecdote and stories in the industry like that. So is it true? Well, we're getting to these examples when we are trying to testing those claims. So this will be a small CRC example. I will be doing this thing called round trip. So I will take some data, encode it as JSON, then decode as JSON back. And of course, this is something that you could do in unit tests to make sure that encoder and the decoder are matching implementation, so that if you send something in from one server to another, when the another server will be decoding stuff, it will get exactly the same thing as you send. You could also do this for the benchmarking reason, you can quite easily make sure that the code what you generated is fast enough. Serialization is one of those things that are bottlenecking our code when we are writing real-world applications. But for this particular test, I used this really, really nasty case class. And by that I mean that this outer class has some inner class, which has another inner class, which has another inner class, and some of those fields are repeated, and so on. And just by experience, I know that this kind of stuff will be really heavy on the compiler. So the semi-automatic version of this code is different by the fact that I had to manually add those 10 lines, deriving implementation of encoders and decoders for every single inner type before I get to the derivation of the outer type. So in theory, it shouldn't be hard on the compiler because what I will be compiling is literally a single file. The definition of JSON is taken from CRC, so I'm not compiling that. The classes I'm using for testing are in another module, so they are not part of this test. How long it will take to compile that single file? So compilation of a single file, which is I don't know, 5 lines excluding imports, maybe 20 including imports on semi-automatic derivation. It shouldn't be tremendously slow, right? So on Scala 2.3, the call JVM test, which under the hood is using shapeless, took something like 14 seconds. Semi-automatic version has 12 seconds. So single file taking more than a second is kind of surprising, I guess, at least for people who were not seeing these things before. Warm JVM is a little bit better. If you keep on clean, compile, clean, compile, clean, compile, after a while Scala compilers warms up a bit, but even then it's like 4 seconds against 3 seconds. Much better, but still people could be surprised why it takes so long. Surprising stuff are happening on Scala 3 because there the automatic derivation of this single file took me 46 seconds on cold JVM and 16 seconds on warm JVM. There you can really see that semi-automatic derivation takes much less because it's 10 seconds against 1 second. So you could really see why people were choosing semi-automatic derivation. Well, kinda, because we are still like wondering why the difference is so small on Scala 2.13 and so huge on Scala 3. Before we like try to guess why, we can also look at the performance. Like we are generating code, so supposedly the performance should be the same, right? Whether we use automatic or semi-automatic derivation. And sorry for just copy-pasting stuff from the Java benchmark harness as opposed to making nice little graphics. But if we look at Scala 2.13, we can see some difference. Not big, but there is some small difference that that we could, probably for some people it would be negligible, for some people it wouldn't, but those compile times, like, they're really close. However, on Scala 3, we can see that there is an order of magnitude difference whether we are using automatic or semi-automatic derivation. Like, if you are using CRC and you derive codecs automatically, then for those pathological cases, at least those that I produced, you could get 10 times worse performance. So probably something that people pay attention to if they are worried about all this stuff, if they are using stuff in production. So how we could explain those results? If someone follows the history of Scala 2 development and reads all those nice little PRs, they could see that the author of Shapeless, Miles Sabin, were doing some attempts to optimize the compilation times. So he made one PR, which was closed, then another PR, which was also closed. Finally, yet another attempt was successful and it got merged. Then he made another optimization which was merged, and so on and so on. And in one of those PRs, he was boasting that the size of that when he was comparing how long it took for something to compile in seconds, depending on the size of the, let's say, a case class, then you could see that before the optimization, it was really bad. Why? After the optimization, it's, basically it's an order of magnitude better. So it's much better. And when you read those messages in those PRs, you can see that they tried to have those things merged in Scala 2.12, but they didn't get it in time. So they decided to do this in Scala 2.13, and attempts to backport it in 2.12, I think they failed or were like scrapped. So people who have experience with automatic and semi-automatic derivation before 2.13 still remembers times before those optimization took place, and you could see that the difference could be much prominent than today. On the other hand, when it comes to Scala 3, you could see that those PRs from Scala 2.13 were ported to Scala 3, but apparently there are differences between how Shapeless works and how mirrors are working in Scala 3, so those optimizations don't matter as much. some new optimizations have to be made in Scala 3 to, you know, make that gap smaller. But were there any like other attempts to improve performance, like other than semi-automatic derivation, obviously? One such attempt was Magnolia. This library was written as an alternative to Shapeless, or nowadays also mirrors, but at the time only to Shapeless. And it's boasts about better API. So if you want to start doing this type class derivation business, it supposedly have better API than Shapeless or mirrors or whatever. One of the reasons why many people are using this. It also boasted better performance, better compilation times, and better error messages when the derivation fails. So let's start with the last claim. We have this nested hierarchy of classes, user which is having address, and address is having a street, and on purpose decided to encode the name of inside the address as something that seriously, like, you know, cannot work with out of the box because I'm using nothing and either, things like that. Just to make sure that this derivation would fail and see what kind of errors would be produced. And we were starting with semi-automatic derivation. So I have several implementations of this. 2 of them are provided by CSC itself. Magnolia, I had to encode myself. So Shapeless, if we fail in this nested field, well, it would still help us, telling us that, sorry, we could not derive it, because we are using semi-automatic derivation and we are implementing all of these intermediate types ourselves, then, well, we know where the derivation failed because the compiler is pointing us to the actual line in the code. And that's the only help we're getting. Mirror, in Scala 3, well, they're able to tell us, sorry, we failed to find an instance for this specific type. So it's a little bit more useful, not that it failed, but it failed because of this. And in case of Magnolia, we're seeing something like, inside the class of this name, in this field, we were not able to handle it because there is no implicit for this field. So quite the detailed message. Probably even beginner would be able to figure out at least what to ask around when they try to fix this kind of error. But this is the semi-automatic derivation. If we are talking about automatic derivation and we are failing this field in deep nested in the hierarchy, you always get only could not find implicit value. So if you are using automatic derivation, all those 3 libraries are equally bad for telling you how to fix this nested stuff. Sorry. So what about the compilation times? A reminder, we are doing this round trip when we are generating decoder and encoder. So on Scala 2.13 nowadays, there isn't that much difference when it comes to compilation. You could see that automatic derivation is slightly faster, but not much. Automatic derivation almost as fast as Shapeless, probably thanks to all those improvements by Malice Sabin. Before Scala 2.13, probably the difference would be much bigger. Interesting stuff is happening again in Scala 3 because Magnolia, instead of helping stuff, it's making stuff worse. We could see that using Magnolia instead of mirrors on Scala 3 increases the compilation times, so that in some cases, at least for my examples on my computer, I had to wait for the result for over a minute. After a warm-up, the results are better, but still worse than with just simple mirrors. And that's because on Scala 3, Magnolia is implemented on top of mirrors, so whatever overhead you have when it comes to compiling mirrors, Magnolia just adds something extra on top of it. in Scala 2, Magnolia was implemented with macros, so it was not using any of the stuff that Shapeless is providing, so it could improve some things, and probably that's why many people were starting using Magnolia in Scala 2.12. But how does it translate to the runtime? So when we look at the benchmarks, we can see that Magnolia is slightly better on Scala 2.13 than Shapeless. Again, maybe there were some optimizations which made the difference smaller in Scala 2.13 than before, but if you are using like a recent version of those Scala 2.13, well, the code that it generates is, it's not a deal breaker if you use Shapeless as opposed to Magnolia. On Scala 3, well, we can see that semi-automatic derivation with Magnolia gives you better results, like 25% in this case, than mirrors. So you could see that there is some optimization when it comes to semi-automatic derivation in Magnolia. But if you're using automatic derivation, you can see that it is an order of magnitude slower than the generic auto. I have some suspicions that it's related to having those really, really big inlines that JVM seems that, okay, the method that you are generating is too big to optimize, so I'm giving up. So interesting things are happening on Scala 3. So if you ask me, those approaches, well, they differ when it comes to implementing the library, but for you as a user, there isn't much difference. A little bit better messages if you have semi-automatic derivations, but more or less the same results for you as a user. Sometimes catastrophic compile times when you're not expecting it, but other than that, like no difference. So since we are talking about JSON, we are using JSON libraries as an example, so JSON Interscala is a library that does things slightly different than CRC. Performance is a priority for them. So every single design decision that this library is making is about performance. And it first no automatic derivation, because when you have automatic derivation, you are creating instances of your interface for all those intermediate types. All those instances obviously have to allocate some memory, and memory allocation is very expensive, so let's try to avoid it if possible. So it also like not using any sort of intermediate instances. But you might ask how it avoids that, because if we are using Shapeless or Magnolia, all of stuff, and we get used to read type class as type level as now to Shapeless or whatever it was called, you got used to this idea that we have those small implementations and we are always combining them together, and all of those implementations have to exist as a separate instance of this trait. So how does JSON approach this differently? If we look at the code, we see that we only have to create one instance. But this one instance is handling things recursively inside. When it will see that, okay, I need to handle this out type. Okay, so let's then see what field it has. Let's generate the implementation for it. Oh, it has another case class, so let's inside the same macro generate implementation for that. Then it says that it has another nested class, another nested class. All of that stuff is happening inside the same single macro without relying on fetching implicits from the outside. Implicits are only used to override the behavior, to provide your own, providing your own codex if you want to somehow modify the behavior in whatever way possible. The API is slightly different than CRC. It has either throwable as opposed to this AST from CRC, but basically conceptually it's very, 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 very similar. other than the fact that you have to provide this single implicit, but this implicit is handling things recursively with all the nestings. If we try to draw how to Circe handle stuff, we can see that this diagram looks a bit more complex. And it looks a little bit more complex because if we like stop reading the things and just zoomed out, we could see that Circe and all of those libraries with the same approach as Circe tries to delegate everything on the compiler and implicit search. If you have any sort of branching, do this, otherwise do that, otherwise do that, it's dumped on the compiler and the typer and the type checker. In JSON-eater, because it has macros, those things exist as an if-else's written explicitly by the author inside the library. When we want to provide some built-ins in Circe and all those libraries that are working like Circe, we have to provide those instances explicitly, and they have to be somewhere in the implicit scope. For JSON-eater, those things are encoded somewhere in the macro. It just is. You have this type, okay, I have this special place in my code which tells me how to handle that stuff. So it's a bit harder on the author, but perhaps it's better for the user. So let's see if it is. Is all that like gibberish talking about JSON they're worth anything? So as you can see, JSON-eater is working slightly better than semi-automatic derivation when you look at the both cold and hot JVM compile times. I'm not sure why there's this bump for JVM on Scala 2.13, but when I was rerunning the code a few times, it was consistent. So I guess it is what it is. But we can see that it consistently is better on Scala 3. It's faster than both Magnolia and Mirrors when it comes to compilation. And as a reminder, this code has 1 implicit as opposed to 10. So I believe it's much more user-friendly if you get better compilation times while writing less code and without macro optimizations. So what about the runtime performance? Perhaps it's a trade-off. We have better compilation times, but the runtime is trash. Well, it's 3 times as fast. So not only you are getting better compilation times, you are also getting better performance. At this point, I have to admit a little bit that I am slightly cheating because Circe is converting case classes into this JSON representation, and when it parses, it also like takes this JSON representation and turns it into a case classes and seal traits. And JSON Scala is handling strings or input streams. So if you were using if you were writing the normal code when you are taking a string, decoding it into as JSON, and then decoding this JSON as this actual type that you want, this difference would be even bigger. So I'm kind of cheating, but I am giving basically Circe a head start, and it's still failing. But we can ask, okay, can it be automatic? Because we still have to write that single implicit, and it might be annoying sometimes. So this is the problem that I had in my own library in Chimney. And again, I am not going to show you Chimney. I'm only going to show you that we have similar problem. We wanted to have the derivation that should be recursive. We wanted it to only use implicit to override the behavior provided by the library, whether that existing behavior is doing something out of the box or failing. Sometimes we don't want to replace failing with support for your own types. But as opposed to JSON, we wanted to support automatic derivation without breaking those 2 rules above. So long story short, we came up with this weird pattern that basically we split the type class into two things. One of them is intended to be used by the user or by semi-automatic derivation, and then we have this dedicated auto-derived type, which is always returned by automatic derivation, but which is invisible to the macro when it looks for implicits. It has this slight little downside that we have to use the wider type when we are using extension methods. And in macro, we have to be careful to only use this more specific type and never the wider type, because there is this, subtyping relationships, and you can all study all of that stuff in your free time, because you are not really interested in this. You are only interested if it can be used outside of Chimney. And the answer is yes. I spent some time to write a wrapper of our JSON eater, only Scala free, because it was easier. And with this wrapper, I only need to do this one import, call all those methods provided by, also by my wrapper. And it would also use that recursive approach with only using implicit to override stuff. And it looks, if you look at it, it looks very, very similar to CRC with automatic derivation. But if we compare it to CRC with automatic derivation or semi-automatic derivation, it's only on Scala 3, so look only at the right side on the blue bar. We can see that there is small overhead over row JSON eater, because I basically wrote a wrapper around it, but it compiles around the same time. So we have something which is much more convenient than CRC semi-automatic derivation, compiling fast, something much more convenient by CRC's semi-automatic derivation, basically as convenient as CRC's automatic derivation, but compiling faster than its semi-automatic derivation. So, sounds really good. If we look at the benchmarks, we can see that the overhead is visually unseen, at least by me. So, also no drawbacks. But of course, you can have some dubs like, okay, JSON eater was built for performance, CRC was built for like other stuff. And it isn't like, fair comparison considering that those libraries might have different philosophies, and it's like apples to oranges. You cannot even guarantee that those differences are specifically to the differences in derivation. It might be different in something else. And this is a fair critique, which is why I decided to do a more fair comparison. So I basically wrote my own type class. If you were using CRC, you probably saw something called show. This is like the simplest example of how to do typeless derivation. It's basically CRC's way of doing a better toString. Except there are some extensions to it called showPretty, which is like toString, but with those nice indentations for nested case classes, nested fields, and stuff. So I decided to do exactly the same thing, except instead of concatenating strings, because I didn't want to, I decided maybe I would improve things a little bit if I was just using string builder and appending to the string builder rather than concatenating strings. Maybe it would be cheaper, at least it would be funnier for me. So you can see that I had this sort of like type class. It should have this API, and it should print things like that for the code I'm showing in the middle. And once I had this API and was having some code to print, I decided to implement it as automatic and semi-automatic derivation with shapeless on Scala 2, then implement it as automatic and semi-automatic derivation with mirrors on Scala 3, then automatic and semi-automatic derivation with Magnolia on Scala 2 and 3, and finally with what I call sanely automatic derivation using macros. And I help myself using Chimney microcommons because some of the stuff that I'm using inside Chimney I extracted as a separate macro utility. And with that I implemented this stuff for Scala 2 and Scala 3. So I believe that should be quite fair comparison. And well, my first approach looks like this. Sanely automatic derivation is at the end, so well, not great nor terrible. Like, at least it's better than automatic derivation with shapeless, I guess, or with mirrors, surely, but still slightly worse than Magnolia or semi-automatic derivation with shapeless or mirrors. Benchmarks, well, with benchmarks, it's also nice, but you could also argue that Magnolia works better or that semi-automatic derivation works better, so someone could think that, hey, sorry guy, your experiment kind of failed. But then I remember that JSON Eater had this one more trick, that when it reuse some stuff inside this code, it basically creates, like, inside this generated code its own defs, which you use to kind of cache whatever it already derived, so that when it see the same time another use in the same macro twice and thrice or more, it just defer to this def so that it would not have to derive it again, inline it again, just reuse stuff, reuse the work it already did. And it was well, not necessarily a simple change. Initial work was requiring me to do some new utilities, but I extracted it to Chimney microcommons, so right now it's a simple change, something that you could implement with a, let's say, a single PR, very non-invasive PR. So you can ask, okay, it's non-invasive PR, so would it make a difference? Well, it does, because right now this code is compiling the fastest of all of them on every platform, irrelevant if it's cold JVM or hot JVM. And also working faster on every single platform. Irrelevant, so it's it's benchmarked, so they are already warmed up. But yeah, this sanely approach now works better than shapeless or Magnolia or mirrors, Scala 2, Scala 3, automatic, semi-automatic. So for something that requires you only to have one import and then it works, better than something which requires you import and several things manually. It sounds kind of nice. And also, as a bonus stuff, debugging is better, because if we are doing everything inside a single macro, and if we decided we want to fail in this nested field deep down in the hierarchy, we are able to show in this macro message that which type was the cause of the failure. If I spend a bit more time in this project, I could tune this error message even more. I could say that this thing happened in this field of this class. I could show how much the derivation took. Obviously, I can also aggregate the failures if there would be several things which are failing inside the macro. I could show all of them at once, as opposed to making you fix one thing, then compile it, make it fail again, then fix another thing. You could fix all those stuff in a single step before recompiling stuff, so that's a huge help. And also because macros allow us to, and here I use this nice thing called X macro settings, which is something which allows you to provide settings to the macros, which hardly any macro library uses, but there is a possibility, and people should start using it more. So with this thing, I told my macros, okay, be so nice and log your logic. And then I could have this nice real structural log telling me what the macro did. Okay, so now it's trying to use implicit. Now it's looking if We already made some dev inside, which is using this, and then try to use built-ins, case classes, sealed rates, and so on, with those nestings for every single field. So you can, fine-tune this kind of logs to your heart's contents to make things as easy to debug for you and your users. And also nice stuff, you don't have to use print lines for that, because macros have this thing like reporting and info errors, which means that if you would enable that stuff in Scala C macro options and run this inside Visual Studio Code, you would see that the dashed line showing you that there is some info, and once you would hover your mouse over it, you could see all of that log inside your IDE without having to look at the output of your build tool. So it's really, really convenient, and I believe people should start using it more, because one of the things that you could provide with this kind of logging would be like, the final expression. So if you wanted to see, okay, but actually what is the expression that this macro is generating? Well, you could just, enable that one little thing in your build tool, hover, scroll, and see, oh, this is what it generates. And that's really, really good when it comes to debugging stuff and figuring out what your macro is doing. So that's all that I had to prepare for today. So I might go to the summary. Yes. So last year there was this Virtus Lab Scala survey, which was questioning, okay, what are those things that are making your life miserable? What we could do to help you fix stuff, make your life better, make you more productive. And 53% of developers were complaining about the compilation times. And I'm not telling it's always typeless derivation, but a lot of that is typeless derivation. And the fact that all those libraries out there, almost all of those libraries out there, are picking the way of providing typeless derivation, which is not compiler friendly. So perhaps we could start giving the library developers feedback that they might be able to do something about it, that they might improve the compilation time, perhaps even improve the performance in the runtime, surely improve the error messages, because implicit not found, sorry, it's 2024. We could do something about it. And perhaps then we would have less people complaining that Scala is hard, that Scala is impractical, is academic, and so on, because we can really make this typeless derivation that a lot of people rely on in their jobs easier. It's just a matter of applying the right utilities. I'm not going to say that all these libraries like Shapeless, Magnolia, Mirrors, CompileOps are wrong, bad, etc. Because if you look at the code I had to write to implement those benchmarks, you could see that usually it was something like, 15 lines of Shapeless against 500 lines of macros. So you could see that if people had to start with macros, they would just give up, and we wouldn't have CRC, we wouldn't have pure config, we wouldn't have all those variety of libraries that we have out there. But if we want to have production-grade libraries, if we want to have libraries which are friendly to users, friendly to developers, which we could recommend people to start using this stuff, it's better than on Java. And unfortunately, we have to give feedbacks to the developers that at some point they might need to move away from those stuff. That perhaps those libraries are really good for prototyping, for fast iterations, but they are prioritizing the library maintainer's experience over library user's experience. And if we want for Scala to not die in the next 5 years, perhaps this is something we need to think about and do something about it. And also, if someone is hoping that, that maybe in 5 years the Scala compiler team makes some super optimization and all of those problems disappear, this improvement is something I could do in a week with my own library. And all of those improvements that Miles Sabin was doing to Scala 2.13 took him several years. And I could still beat him with a single PR in my code without waiting for Scala devs to fix compiler, because it's super complex machine. So I'm afraid the only way for us to improve our experience if we took things in our hands and start fixing our code without waiting for the compiler team to try to fix our code in their code. And with that saying, I also want to tell you that, okay, I don't want to force my approach on the code on you. I only wanted to, I don't care if any of you would ever use my semi-automatic derivation, if anyone of you likes it. But if that would inspire any of you to give some feedback to the library developers, and if you are a library developer, to start challenging some assumptions that our community was living over the next several years, that this is the only way for building libraries. And if you find your own way, and this way will make Scala better, then I will be happy. And with that said, thank you.
Many thanks for the talk. That's impressive. If I understand you well, currently it's only available in Chimney commonly?
Yes. While working on migration to Scala 3, I had to, because of Chimney is a very, very complex library, I didn't want to have two code bases to maintain, which are only held together by unit tests. We decided that as much as possible of the business logic should be shared. So I developed a way of sharing the logic between macros on Scala 2 and 3, and part of that was also sharing a logic of utilities for parsing things like case classes and anivals and seal traits and stuff. And because I didn't want it to live in the same module as Chimney to pollute stuff, it ended up as a separate library called Chimney Macro Commons. So it exists for a year, maybe a year and a half, something like that. I have to warn you that there is no tutorial or no documentations about this library. The only documentation is Chimney and maybe the examples you could see in this repository because I'm using it here. But yes.
Thank you. If at some point some other library developers want to use it, if it's useful for them at some point, what I understood is for them, the cost would be to have much more boilerplate code to write for it to profit from fast automatic derivation. Is that it?
Yeah, like if you want to write macros, unfortunately you have to prefer for that you will have much more code to maintain. I believe that if there was some library, for now I only know one, which would help in this task, it would be great. You could still have this overhead of maintaining macros, and they will always be much more, they will have always much more overhead, for at least when you are starting, than writing things with just implicits. But the more and more complex your logic gets, at some point when you have those inline devs with those stuff, fetching things, like writing code with simple if-elses start getting easier, even with all those overhead of maintaining macros. But it's definitely not something I would recommend anyone to start with. If you want to have a typeless derivation library, start with all the stuff like shapeless, implicit macros, because they're much better to learn, to get some feedback, to understand how it works. Only when you are no longer your main user, no longer the person who, okay, I'm missing something, so well, I will add this to this library. Some other people, well, there are none. So I don't have to care. Once you grow out of this, once you start sharing the library with other people, once they start relying on your library and they would need it to work, they would need it to work fast, be easier to debug and so on, then you might decide that perhaps implicit-based approach is not very good, because it's also very, very hard to keep things binary compatible, as you can see with CIRC, which is breaking things with every other release, at least if you are using those, type of derivation and stuff. So yeah.
By the time I walk to the next question, quick update on the community body. It will start at 6:30 on the hour.
In the case of the automatic derivation, if you have to edit, you have to see twice. Will Scala be able to catch the result of the first derivation, or will it derivate that twice each time?
Basically, you should assume that every single time you're using automatic derivation, it's not cached, but one of the reasons why the semi-automatic derivation and automatic derivation started getting similar results on Scala 2.13 was that the compiler team, Miles Sabin, basically implement this kind of caching. But this caching, you should also assume that when it works within the scope of a, let's say, single file. So if you are deriving the same stuff in several places, you should probably assume that it's going to be derived several times over. However, if you have this, sanely approach to automatic derivation, the cost might be much smaller. So before it bites you, it will take a lot more time. You would have to use those things in a lot more places at once before it will bite you as much as it bites you right now with the current approach.
In your benchmark numbers, I expected to see some radically different compile times, but I was surprised to see that the runtime performance sometimes also varied by a factor of tens of times. Do you have any insight into? I would have assumed that sort of once the compile finished, that the resulting bytecode was more or less the same. Do you have any insight into where that extra time is coming on the ones that have slow runtime numbers?
I didn't do very deep investigation, but I have some educated guess, because in one of the reasons, if you look at the code, you see that the nesting of these classes is like 5 levels depth. And initially I started with 10th level depth, but then quite often I had issues like, I'm sorry, but your code excluded the maximal size for the method on JVM. Or sorry, but your code is you have Stack Overflow the compiler or things like that. So the 5 was the border number on which I could still compare those libraries without these approaches, without one of them being basically unusable because the compiler would give up. And in some versions, when I was testing macros, I saw that if you are naively inlining stuff, you could easily exceed maximal size of the methods on JVM. So I had to use a trick to put things into defs, so that because def, then it would be smaller chunks in the bytecode and things would work. And after I used this approach with explicitly using the def with caching, for caching like this second approach to macros, then it was no longer necessary because that was handling it. But my intuition, again, I haven't validated it, but my intuition is that when you're using inline def with mirrors, it naively inlines everything in the same method. And because it's exploding the size of the method, you might think, okay, inlining is good, but the JVM has some limit on how much bytecode it tries to compile into optimized code, and at which point it said, okay, this method is too big, I'm giving up, I'm only going to interpret this. And my guess is that like mirrors and Magnolia with this automatic derivation inlining everything with no respect for whatever, generating so huge methods that the JVM says that, sorry, I'm not gonna optimize that. I'm not gonna run C2 compiler. I'm only gonna interpret that, and then you get this huge hit in the performance. But that's not just educated guess. I didn't do any sort of investigation. This is just my intuition.
Any other question? Thank you very much.
Thanks.